Good morning, everyone. I, Lovely Singh, working as Assistant Professor in the Department of Physics at AKS University, and your presenter for this two-day international webinar on recent contributions of chemical science to modern society, organized by Govt.Girls P.G. College Satna in collaboration with Faculty of Basic Science AKS University Satna. Today, we are having many eminent personalities connected with us all over the world to grace our webinar and add glory to the history of AKS University. First of all, I would like to invite our webinar's organizer, Dr. Neelam Richaria, Principal, Govt.Girls Degree College, Satna. Over to Dr. Neelam Richaria, Madam.
Yes,
Okay. Am I audible? Hello.
Yes, ma'am, you are audible.
Good morning, sir. It's an occasion of great pleasure for all of us to welcome our Honorable VC, A.K.S. University Riva, Dr. Rajkumar Acharya ji, as chief guest in the inaugural session of this two-way international webinar. Honorable Anant Kumar Soni ji, Pro-Chancellor, A.K.S. University Satna, to chair as president in this session. In continuation to this, I feel immense pleasure in welcoming our speakers, Dr. Qureshi ji from Saudi Arabia, Dr. Shyam Sundar Pandey ji from Japan, Dr. V.K. Agrawal from Riva, Dr. Vandana Pandey from Kurukshetra, and all the speakers joining to us from different parts of the world. Galaxy of academicians and intellectuals joining this online platform. The topic of the webinar is recent contributions of chemical sciences in modern society. As we all know, chemistry is a central science, and all the branches of science are directly or indirectly connecting chemistry. So, the topic of the webinar seems to be useful, especially at that time when whole world is facing challenges of COVID-19. The discussions of this two-day webinar must give fruitful outcomes for the society. Once again, I would like to pay my thanks to all the guests for giving their valuable time from their busy schedules to this webinar. I am also thankful to Faculty of Basic Sciences, A.K.S. University, Satna, for giving their support and cooperation to Govt.Girls P.G. College, Satna, for organizing this international webinar. Thank you very much.
No?
I would like to invite and welcome University's Vice Chancellor Honorable Rajkumar Acharya Sarji to please say a few words in regards to our webinar. I welcome him for the opening remarks to Dr. Rajkumar Acharya Sarji. So please, over to Dr. Acharya. डॉक्टर आचार्य सर जी, प्लीज आप अपना माइक ऑन कर दीजिए।
ओके,
ओके सर।
थैंक यू। आप सभी का इस वेबिनार में बहुत बहुत स्वागत, वंदन, अभिनंदन है। आज जिस विषय पर विज्ञान की शाखा रसायन शास्त्र या रसायन विज्ञान जो विचार विमर्श के लिए एकत्रित आई है, उस विमर्श में निश्चित है कि आने वाले समय में कुछ अच्छे परिणाम निकल कर आएंगे, क्योंकि जहां तक रसायन विज्ञान के योगदान का सवाल है, तो रसायन का योगदान तो मानव जीवन में नहीं, जीव जगत में और उस प्रकृति में विद्यमान है। जैसे सामान्य भाषा में कहते हैं कि मनुष्य के शरीर में उसका जो पेट होता है, उससे बड़ा रसायन संसार में कुछ होता ही नहीं है। आज प्रकृति में जितनी विलक्षणता, जितनी हम ये कह सकते हैं कि आनंददायकता, जितना वैभव, जितना विविधीकरण विद्यमान है, चाहे वो रंगों के रूप में हो, चाहे वो रसायन के रूप में हो, चाहे वो प्रकृति के अन्य हम जिन 10 इंद्रियों के माध्यम से सब प्रकार की अनुभूति करते हैं, उस अनुभूति में ये सारी बातें निकल के आती हैं। और आज जब हम अर्थवादी संरचना में जी रहे हैं, तो चाहे वो उद्योगों में रसायन विज्ञान की भूमिका का सवाल हो, जिसमें चाहे प्लास्टिक है, चाहे कपड़ा है, चाहे उर्वरक है, कांच धातु, कोयला, कागज, गैस, पेट्रोल, रसायन, इन सबसे प्राप्त जो रसायन है वो हमारे जीवन की रचना का बड़ा एक हिस्सा आज बन गया है। बगैर उसके हम रसायन विज्ञान की कोई संकल्पना नहीं कर सकते हैं। हम सब जानते हैं कि रसायन विज्ञान की सामान्य परिभाषा यदि मैं कहूं, वैसे यहाँ विद्वान बैठे हैं, उनका ये विषय है, लेकिन आम विद्यार्थी भी जो अन्य विषयों के जुड़े होंगे वो जानते हैं कि पदार्थों के संगणक, संरचना, गुणों और मुझे लगता है रासायनिक प्रतिक्रिया के दौरान रसायन शास्त्र में इन सब के परिवर्तनों का अध्ययन किया जाता है। और फिर हम जीवित अजीवित, गैस, द्रव, ठोस पदार्थों से लेकर पाउडर जैसे पृथ्वी के सबसे कोमल खनिज, हीरे और ऐसी कठोर खनिज धातुएं रसायन तत्वों से मिलकर बनाते हैं और उनका अध्ययन करते हैं। जैसा मैंने प्रारंभ में बताया कि स्वयं मानव शरीर ही रासायनिक संयोजन से ही बना है, और मानव जीवन के लिए आवश्यक पर्यावरण भी रसायन तत्वों का ही मिश्रण है। क्योंकि आज हम जिस प्रकार का भोजन ले रहे हैं, यूरिया और ग्रोमोन या रसायन की श्रेणी के ही हिस्से हैं, लेकिन इनके प्रयोग ने हमारे शरीर रचना को कितना वैज्ञानिक या यूं कहें कितना अप्राकृतिक बना दिया है, इस पर भी आज विचार करने की आवश्यकता है। और स्वास्थ्य के इस परिवर्तन ने, रसायनों के दुरुपयोग और उनसे होने उपजने वाले प्रदूषण ने हमारे जीव जगत को भी बुरे तरीके से प्रभावित किया है। आज कृषि में उर्वरक और कीटनाशकों का उपयोग जो हो रहा है, उद्योगों में जिस प्रकार से हम रासायनिक क्रिया का प्रयोग विभिन्न प्रकार के रचनाओं में कर रहे हैं, उस सब का इम्पैक्ट क्या है हमारे जीवन में, इस पर सोचने की आज आवश्यकता है। मुझे लगता है इस 2 दिवसीय सेमिनार में तो विद्यमान है। लेकिन विलुप्त प्रजातियों में हम जब विचार करते हैं, तो बहुत सी ऐसी विलक्षण प्रजातियां हैं जो आज बिल्कुल खत्म होने की कगार पर हैं, क्योंकि उनके समाप्त होने में उनके द्वारा खासकर जो मांस भक्षण करने वाली प्रजातियां हैं, पशु पक्षियों की, जीव जंतुओं की, उन पर इसका सबसे बड़ा इफेक्ट आया है, सबसे बड़ा इम्पैक्ट हुआ है। मृत जीवों के मांस को खाने के कारण जो रोग फैले हैं। कोरोना क्या है? कोविड 19 के बारे में जब हम विचार करते हैं, वो उसके मूल उद्भव स्थान के बारे में विवाद हो सकता है, वुहान है या कहीं अन्य है, लेकिन अंततोगत्वा चमगादड़ से लेके अन्य जीव जगत का भक्षण करने का जो स्वभाव मानव जीवन ने अपना लिया है, उस सबके दुष्परिणाम हमारे जीवन पर आज रासायनिक प्रतिक्रिया के रूप में एक वैश्विक बीमारी के रूप में कोविड ने स्थान बनाया है। लेकिन एक तरफ ये परिस्थितियां है, तो दूसरी तरफ इतने जल्द केवल और केवल रसायन विज्ञान के ही और सहयोग से उसके वैक्सीन की निर्मित भी हुई है। ये हमारे लिए बहुत गौरव की बात है। भारत तो आज वैश्विक स्तर पर एक अलग पहचान लेके चल रहा है। ये जो स्थितियां बन रही हैं, इन स्थितियों में हम आगे अपने विद्वानों के विचारों से विभाग के किन आयामों को नए स्वरूप में और बदल सकते हैं, उसका हम सबको लाभ मिलेगा। क्योंकि विज्ञान मेरा विषय नहीं हूं, मैं कॉमर्स का विद्यार्थी हूं, लेकिन इतना कह सकता हूं कि विज्ञान में रसायन की उपयोगिता वही है जैसे हमारे शरीर में जल की उपयोगिता है। और जल तत्व के बगैर तो शरीर रचना नहीं चल सकती है। ऐसे ही विज्ञान में भी रसायन के बगैर कोई प्रगति और कोई स्वभाव हम नहीं डेवलप कर सकते हैं। मैं महाविद्यालय को, विश्वविद्यालय को इस अच्छे विषय को लेकर आने के लिए हार्दिक और धन्यवाद ज्ञापित करता हूं। साथ ही इस वेबिनार में जुड़े सभी विद्वान अध्येताओं को, विज्ञान जगत के शीर्षस्थ वैज्ञानिकों को मैं युवा विश्वविद्यालय की ओर से अभिनंदन वंदन करता हूं और इस 2 दिवसीय सेमिनार के सफल क्रियान्वयन की कामना करता हूं और अपनी वाणी को विराम देता हूं। सभी को मेरी ओर से बहुत बहुत अभिनंदन वंदन धन्यवाद।
We are very much thankful to Dr. Acharya Rajkumar sir, Honorable Vice Chancellor of Desh Pratap Singh University, Satna, for his words of wisdom and to grace our occasion with his presence. Thank you so much, sir, once again. Now, taking the technical section ahead, I would like to give you about a brief introduction of Dr. M.A. Qureshi, a well-known name in the field of corrosion science. Ladies and gentlemen, and my dear colleagues, we rarely get this kind of opportunity where we are having the opportunity to listen the words of a great knowledgeable speaker of our today's session. Yes, I'm talking about Dr. M.A. Qureshi sir, a renowned name in the field of corrosion science, and in recognition to his outstanding research contributions for his entire work on corrosion science, he recently has been awarded with the Lifetime Achievement Award by the Electrochemical Society of India in January 2021. His significant scientific contributions and rich research experience will be displayed through a video clip as a part of introduction of his biography. I was having a proud honor and privilege to record this video in my own voice, which was played at Electrochemical video clip of Dr. M.A. Qureshi's biography. We request Dr. M.A. Qureshi sir to please off the screen as we have to play your video, sir.
Video.
Please stop the screen, sir. We request you.
Yeah.
Thank you so much, sir.
I did it.
Dr. M.A. Qureshi. I am glad and happy to introduce Professor M.A. Qureshi. He is a leading corrosion scientist of India. He did PhD from KUK in organic
Some video
synthesis
is there.
and
Yes.
completed advanced training
Dr.
course
M.
on the use of
Qureshi. I'm glad
electrochemical
and happy
techniques
to
in
introduce
corrosion
Professor M.
inhibition
Qureshi.
at
He is a leading
CECRI,
corrosion
one of the
scientist
best
of India.
institute of
He did PhD
electrochemistry.
from KUK in
Afterwards,
organic
he
synthesis
developed a
and
corrosion
completed
research
advanced
lab
training
in
course
applied
on the use
chemistry
of
at
electrochemical
Aligarh Muslim
techniques in
University,
corrosion
Aligarh.
inhibition
His
at
significant
CECRI,
scientific
one of the best
contribution
institute
deals
of
with
electrochemistry.
synthesis and evaluation
Afterwards,
of novel
he
corrosion
developed a corrosion
inhibitors.
research
He
lab
has
in
developed
applied
many types
chemistry
of
at
corrosion
Aligarh
inhibitors,
Muslim
for
University,
example,
Aligarh.
heterocycles,
His
polymer
significant
macrocyclic,
scientific contribution
dendrimers,
deals with
functionalized
synthesis and
carbohydrates,
evaluation
amino
of
acids,
novel
and
corrosion
nucleases.
inhibitors.
He
He
has
has developed
developed
many types of
first-time
corrosion
graphene-based
inhibitors.
new
For
class of
example,
nanomaterials
heterocycles, polymer
used as corrosion
macrocyclic,
inhibitors
dendrimers,
for highly
functionalized
corrosive
carbohydrates,
acetizing
amino acids,
environment.
and
Drug
nucleases.
and plant
He has
extracts for
developed
acidizing in
first-time
sweet corrosion
graphene-based new
environments
class of
encountered in
nano
oil gas industry,
used as
for which
corrosion
2
inhibitors
US
for
patents have
highly
been
corrosive
granted. He
acetizing
conducted
environment.
research
Drug
for
and
more
plant
than
extracts for
35 years
acetizing
in the
sweet
field of corrosion
environments
inhibitors
encountered
at
in oil
Aligarh
gas
Muslim
industry,
University
for
and
which 2
IIT
US
BHU
patents have been
Varanasi.
granted.
He
He
has been
conducted
supervised 20
research for more
PhD
than
and 30
35
MTech
years
students.
in the field of
He has
corrosion
published more
inhibitors
than
at
350 research
Aligarh Muslim
articles
University
in reputed
and
international
IIT
journals.
BHU Varanasi.
Currently, he
He
has
has
been
been
cited more
supervised
than
20
20,000.
PhD and
He
30
has
MTech
authored a
students.
book on
He has
organic
published more than
heterocycle
350
corrosion
research articles
inhibitors
in
published by
reputed
Elsevier in
international journals.
2020.
Currently,
He has
been
edited a
cited
book,
more than
Corrosion
20,000.
Inhibitors
He
Science
has
and
authored a
Technology,
book
published
on
by
organic
NACE Houston,
heterocycle
USA in
corrosion
2004.
inhibitors
He
published
has
by
received
Elsevier
many
in
honors and awards
2020.
during his
He
service
has
time
edited
period.
a book,
He has served as the
Corrosion
founder,
Inhibitors Science
head
and
of the
Technology,
Department Chemistry,
published by
IIT
NACE
BHU
Houston,
during
USA
2012 to
2004.
2015.
He
I
has
would like to
received many
mention a few
honors and
honors
awards
and awards.
during his service time
Lifetime
period.
Achievement
He has
Awards
served as
from
founder,
Tribhuvan
head of
University,
the
Nepal
Department
by
Chemistry,
International
IIT
Science
BHU
Congress
during
Association 2015
2015.
and
I
National
would
LT
like to
Award by
mention a few
National
honors
Corrosion
and
Council of
awards.
India.
Lifetime
Third Lifetime
Awards
Achievement
from
Award of
Tribhuvan University,
2020
Nepal
shall be given
by
to him from
International Science
Electrochemical
Congress
Society,
Association
Bangalore
2015
on January
and
21st,
National LT Award
2021
by
at
National
Bangalore.
Corrosion Council of
He will
India.
also give keynote
The third
lecture there.
Lifetime Achievement Award
He is
of
currently serving as
2020
chair
shall be
professor
given to
from
him
past
from
3 years
Electrochemical
at
Society,
King
Bangalore
Fahd University
on
of
January
Petroleum and
21st,
Minerals, Saudi
2021
Arabia.
at Bangalore. He will also give
Now,
keynote lecture
I would like
there.
to show you some of the
He is
slides
currently
on
serving
his
as
work.
chair professor from past 3 years at King Fahd University of Petroleum and Minerals, Saudi Arabia. Now, I would like to show you some of the slides on his work.
So let's start with the most awaited lecture of our first keynote speaker. I heartily welcome and invite Dr. M.A. Qureshi, a distinguished personality, to honor us with his presence. And his topic for today's session is hideous facets of corrosion and its mitigation through environmentally benign inhibitors. May I request and welcome Dr. M.A. Qureshi to have his presence for the session.
Thank you very much.
The outset, I'd like to thank the organizers for giving me an opportunity to present this lecture.
Sorry to interrupt you, sir. May I request Shyam Pandey sir to please switch off your microphone?
Okay.
I'm requesting Shyam Pandey sir to please switch off his microphone, sir. Thank you so much, sir.
So, with the outset, thanks to organizer for giving me an opportunity to present this invited talk of this Satna University. Research for on international webinar on recent contribution of chemical science to modern society. I also thank Dr. Lovely Singh for giving a very nice introduction, very sweet and religious voice in contribution. Now the topic of my presentation is hydrogen facets of corrosion and its mitigation to be environmentally benign corrosion indicator. In this lecture,
Hello. We request Qureshi sir, your audio is not very much clear. Please say a bit loud because I think some network issues
audio.
are there.
Okay.
Okay, sir.
Hello. Yes.
Yes.
Yes. Sir.
Yes, sir. Okay. Thank you, sir.
So the outline includes some basic concept of corrosion, hideous facets of corrosion and its significance, and then fundamental aspects of corrosion inhibitors, mitigation of corrosion through environmentally benign green corrosion inhibitors. Then I will give few application of corrosion inhibitors in industry. What is corrosion? Corrosion is defined as a deterioration of material by its environment. Why metal corrodes? Metals, as we know, obtained from ores are in high energy states, so they tend to go back to the original states, and that is why the corrosion. These are the common examples of corrosion. Testing is well known to everyone. Corroded brass plate. Corrosion causes ugly faces, appearance of the metallic structure. You can see here this fresh both and corroded chip. As regards significance, economic significance, every country loses 3 to 4% of GDP on account of corrosion. The global cost of corrosion is around $2.8 billion. The cost of corrosion in Saudi Arabia is highest in Gulf countries because there are many industries here. Corrosion causes destruction of buildings, and sometimes fatal accidents also take place due to release of toxic gases and fire related. You are aware of release of methyl isocyanate from carbide plant. Bhopal, several thousand people died because of this corrosion. Corrosion is omnipresent. Corrosion occurs in air, water, soil, and even our body, if it is highly corrosive, it causes corrosion of inflammation. These are the basic requirements of corrosion. Corrosion will take place when anode, cathode, and electrolyte are present. There are 4 types of corrosion. Dry corrosion occurs in presence of dry gases, oxygen H2A. Wet corrosion occurs in presence of NaOH. Biocorrosion occurs in presence of bacteria. Hard corrosion occurs reaction of metal with molten salt, and this kind of corrosion is present in turbines and coastal areas. This is the mechanism of corrosion. Corrosion is an electrochemical reaction that involves oxidation at anode and reduction at cathode. There are two kinds of cathodic reactions. It depends upon the nature of the environment. In acidic environment, hydrogen evolution takes place, while in neutral and alkaline environment, oxygen reduction takes place and hydroxide ions. So at anode, metal ions are formed and cathode hydroxide ions are formed. You can test the presence of anodic and cathodic areas by simple pyroxyle indicator. Pyroxyle indicator is consists of potassium ferricyanide and phenoxy. When a drop of electrolyte is placed on iron, at anode ferrous ions are formed and cathode hydroxide ions are formed. So in contact with this indicator, ferricyanide ion will react with iron and give blue color, so that is the anodic area, and what's called phenolphthalein, that will react with OH, the cathodic area, so pink color is obtained. So you can see these nails in contact with electrolyte and indicator. You can very well see blue area and pink area. So presence of this blue color, that shows the anodic area, and pink color showing the presence of cathodic area. There are two kinds of cells responsible for corrosion. Galvanic cell, that is when two dissimilar metals are in contact, so galvanic corrosion will take place. Active metal acts as anode and less active metal acts as cathode. There is another kind of corrosion cell, that is the concentration cell. When metal is uniform, metal is safe, but the concentration of the corrosive species is not uniform, and then this kind of corrosion, concentration corrosion. There are several forms of corrosion. Uniform corrosion occurs all over the metal body. This is the picture you can see. Uniform corrosion. Galvanic corrosion, as I mentioned, you can very well see this of liberty. This is the national symbol of liberty. After installation of 2 months, this got very much corroded and fall down. Therefore, the investigation was found that this statue is made up of 2 metals, one is iron and another is copper. Contact because of two different has occurred, and this is statue has fallen down. Later on, investigations were made, and then the insulating material was placed in between the 2 metals to avoid the contact. Now, this is very fine condition. Whereas corrosion takes place in shielded material because the concentration of the corrosion here are not uniform. Shielded areas less concentration of the remaining area creation of any surface area corrosion. Pitting corrosion mostly takes place in chloride containing environment. Stainless steel is very susceptible to this kind of corrosion. The chloride ion break down the passive film which is present on the leg of your cell. Intergranular corrosion takes place grain boundary, and because of and mostly in welding condition. When this stainless steel is welded, chromium present in steel gets precipitated with grain boundary, and chromium concentration cell is formed. So because of the formation of the chromium concentration cell, selective leaching is one of the metals that can be removed from the alloy. For instance, heat vivification is one of the very popular example. In this case, heat is removed from the brass and the material becomes unfit for practical application. Erosion corrosion, and this is mostly encountered in elbow joint because of the mechanical action of flowing leak on the metal. Fretting corrosion is another form of corrosion because of the mechanical action of body on the metal surface, and the most prevalent example is this ball bearing. Here, this kind of corrosion. Stress corrosion cracking occurs because of the joint action of the tensile strength and corrosive environment, and because of this corrosion, the silver bridge collapse because of the stress corrosion. Because of the heavy traffic causes stress, and inside and beside this is also collapse. Hydrogen debris is in acidic environment. Hydrogen may enter into the metal and blistering, and because of the blistering, accumulation of this hydrogen inside the metal, the material becomes there are many factors which affect corrosion. One of the most important factors is relative humidity. There will be no corrosion when the relative humidity is 45. Above this only corrosion will take place, and you can minimize this corrosion by using these agents. Corrosion also takes place in highly polymer, but the corrosion rate is very low. You can also see this iron pillar. This is called rust-less beauty of the India. It was established constructed by and it is 1500 years and no significant sign of corrosion is there. A lot of researchers were carried out the IIT professors, especially Professor Balat, found because of the presence of ferric oxide film, this protects corrosion. See this corrosion map of India. The importance of this map is you can see this shows the corrosivity of different regions. You see the blue region near the ocean, and pink region they are highly corrosive environment. Therefore, the special kind of the alloy or material and the other areas yellow white. Here corrosion rate is very less, therefore it is ordinary material. So the importance of this method, selection of material. 4-way diagram is of iron shows the effect of pH on metal. You can see the iron undergoes corrosion at all the pH, acidic pH, neutral pH, and highly alkaline medium. There is a very small area that is the 10 and 11 pH where the corrosion of iron does not take. Otherwise, most of the area, most of the pH is undergoes corrosion. Therefore, lot of precautions are required to protect corrosion. These are the important methods of corrosion control. We can minimize corrosion by design improvement, by applying suitable coating on the metal, by using corrosion resistant alloy, by using cathodic emission protection, and by using. So by this tactics we can protect only 35 to 40 percent by these technologies. So a lot of efforts are required to protect corrosion. Use of inhibitor is one of the important methods of corrosion control. So inhibitor is a chemical substance which reduces the corrosion when added in porous environment in appropriate concentration without significant changes. So one of the most important things about definition is that any substance which regards the corrosion is the most important thing, that the inhibitor should not change the concentration of the porous environment. For instance, hydrogen hydrate is used for corrosion protection in boilers, but it is not considered as a corrosion inhibitor because it reduces the concentration of. Similarly, acid corrosion can be checked by adding alkali, but alkaline solution cannot be considered as a corrosion inhibition because it changes the pH of the. These are the important criteria of inhibitors should be effective in preventing corrosion with lower concentration than and corrosion inhibitor is also most cost effective and also application. One example regarding the cost effectiveness, construction of new bridge costs $700 per cubic meter. And if you use inhibitor, then the cost is slightly increased by $50, but the rehabilitation cost of bridge is $3,000 per cubic meter. Therefore, corrosion solution is better than you should take this. There are many applications of inhibitors, petroleum, gas industry, steel industry, sugar industry, concrete, corrosion prevention, art, and steel industry, desalination. All these industries are also. And if you look at the market of corrosion inhibitor, then around 6.9 billion was in 2016. Now this market and particularly the power industry and oil gas industry. Corrosion inhibitor development is a challenging task due to wide variety of corrosive environment and nature of metallic materials. You cannot use a single inhibitor for various corrosive environments or different different corrosive environments as well as different metals. Second important thing, the appropriate concentration is required. Appropriate concentration of inhibitor is always required. Appropriate concentration is also required, and especially for anodic inhibitor. And if appropriate concentration is not there, then the inhibitor causes more corrosion than without inhibitor. On the Evans diagram, you can see that C2, that is insufficient concentration, is more corrosive than without inhibitor. This is the classification based on the electrochemical nature. Inhibitors based on the electrochemical nature. Anodic inhibitors retard anodic reaction, retard cathodic reaction. If mixed inhibitors are there, they are capable of retarding both anodic and cathodic reaction. Based on practical application, acid, cooling water inhibitors and volatile corrosion inhibitors, There are certain guidelines for improving corrosion indicator performance by incorporating heteroatom electron donating group in parent molecule, by increasing the size, by increasing the carbon chain length, by increasing molecular weight, by enhancing the solubility, by introducing weight and exposure, by introducing color. So we prepared large number of compounds to illustrate the effect of these factors on inhibitor performance. You can see that the efficiency of this inhibitor is highest when donor methyl methoxy group is present, and it is less electron rich. In another picture, you see long chain compounds are more effective. Similarly, synergy is also very important criteria by which we can improve the performance on the inhibitor. You can when the thiazole derivative, the efficiency, maximum efficiency at 500 is 98%, but the same efficiency can be obtained with mixed agent again. So you can see here 100 ppm of inhibitor, very little amount of Ki in the same performance. So the synergy is very important for increasing the performance and what we call the cost of the inhibitor formulation. There are various kinds of mechanisms by which inhibition takes place. More absorption inhibitor job to buy electrons on one electron from the metal. There are various methods for generation of corrosion to weight loss. We immerse the metallic material into corrosive environment, and after some time, in absence and presence of inhibitor, and then we check weight of the mutation, then we can find out the inhibitor efficiency. There are various electrochemical factors. Weight loss method, one drawback is it takes long time, particularly if we check the corrosion inhibition in concrete environment, then several months are required. But there are these electrochemical methods. You can test corrosion inhibition performance within few minutes. So there are various methods and medium polarization methods. Here we measure the polarization resistance of find the corrosion inhibition performance. The advantage is that it is very quick method. You can see you can find corrosion rate, but the limitation is that it does not give any mechanistic information. The another is your second polarization method. Here we can find out the mechanism of the reaction, whether it is anodate or lit, and we can also find the effectiveness of inhibitor, because in presence of inhibitor the current is constant. The chemical method is more advanced and it is more important regarding the mechanism of inhibition, that we can find out whether the reaction is transformed to help us with another recent method is electrochemical frequency modulation. We are also within a minute we can find the corrosion rate of corrosion rate of the metal, and we can see the advantage. And you can also validate the experimental data by checking or by comparing the experimental quality. Scanning electrochemical method is also one of the very recent techniques, and the importance is that we can find out the fitting corrosion, which we cannot find with the help of other methods. We we scan the factors by microscope, and we find the changes trend. Here we have studied the copper corrosion in sodium chloride environment, and you can see the significant corrosion reduction in the corrosion takes place in presence of inhibitor. The current variation from 600 microampere to only 0.36 can this is the experimental setup which we use for studying participation. There are various methods of surface characterization, same scanning, electron microscope. This gives only the smoothness of the emitter. AFM, we can find out the extent of roughness, and there are XPS method also we can find out the presence of various elements and binding energy we can find out with the help of this. And one of the most recent techniques is also TOF sync, that is the time of flight secondary and master structure. What is the brief principle is that the metal is bombarded with high energetic beam, and the secondary ions which are released from the metal surface, they are analyzed by their mass and the time of arrival in flight. And with the help of this, we have been able to uh, characterize the metal surface using this technique and the Tajol molecule. And we got we can easily find out the mass of the adsorbed material on the metal surface. So we got an opportunity to study this sample in France with the help of Professor Marcus and for computational method is also one of the important methods for giving the preliminary test about the reactivity of the emitter. The key step is that we find out the energy difference between the HOMO and LUMO radiation. And from this energy difference, we can say which one is more efficient. So for preliminary investigation of the compound, we can know which one is more effective. So important conditions for effective ignition that HOMO, the difference between the HOMO orbital or the energy gas should be lower for higher efficiency. So we have synthesized three beam derivatives to test the correlation between the quantum chemical parameters, and then we found that among these three compounds, the parent compound having the least delta E value 2.4 with highest efficiency, which we have confirmed by the experimental data. And the other compound which are having nitro group, so since the nitro group reduce the efficiency of the compound, so their delta E value is high. And this Professor Paul Enestar, he gave green principle, and by use of these green principles, we can synthesize environmentally benign collagen inhibitor without needing any practical solvent. So these are the important guidelines by using environmentally benign chemicals that is starting material, and to know the environmentally benign or green emitter, the toxic value should be more than 300. We can use microwave and we can use ultrasound method. We can use single step synthesis for synthesizing compounds, renewable raw materials, plant extract, experimental, safer solvents like water. Catalysts can also be used. So all these guidelines help us. And green criteria, LG50 value more than 300 are considered environmentally grand emitter, and the values ranging from 5 to 300 they are considered toxic emitters. So what we do to find out the process of performance. So given the non-toxic element, you can see the toxicity value is more than 1000 here, and the product toxicity is also very high. This LD50 is also very high, 1480. And this we have found out with the help of software. So this is a green chemical because this LD50 is more than 300. So we have come up with 1400. Catalyst is also very Reps are also considered because they are very well. We have studied various reps as but reps are slightly costly, so we have expired reps, and we have found that the expired reps also give almost same indication like these are the microwave methods, ultrasound methods as compared to conventional methods. And this is also an important approach for the technique of giving indicator. Single step technique. So single step is more convenient because number of steps are reduced in synthesizing and time is also saved, energy is also saved. So by using single step multi-component, we have synthesized large number of compounds by using this glycolate reaction. All these compounds. You can see this chitosan. Chitosan is obtained from the chitin, that is the exoskeleton of this shrimp, dry sodium hydroxide treatment, and this chitosan is it is effective up to 83% at 1000 ppm. But its performance can also be increased by modifying the structure with various kinds of compounds like trigo and aldehydes. So you can see that the efficiency of chitosan can be increased from 83% to 93%. And the concentration of the inhibitor can be reduced from 1000 to 50 ppm. So chemical modification of chitosan plays a very important role in performance. And this work has been highlighted in detail. And two applications are defined. Corrosion industry, corrosion takes place in the industry. And there are two important areas: acidization of oil. Acidization of oil is used for stimulation for oil production. Commercial inhibitors are very toxic, so we have developed new inhibitors, and we found its efficiency, its performance is very high, and toxicity is very low. So commercially, inhibitor the corrosion rate is not 60, but at 5000 ppm, and our inhibitor there is only 16 MPy corrosion rate at 500 ppm. And this was we have also developed a inhibitor for sweet corrosion environment. Sweet corrosion environment means sodium chloride saturated with carbon dioxide. So lot of corrosion occurs. The problem with current sweet inhibitors, they are high cost. They are synthesized by T-square, toxicity also high. So to obviate this defect, we synthesize a green inhibitor and very high performance of 95%, even at very low concentration. We have found chitosan based chitosan solution. We also prepared a chemical barrel that was also found to be very effective. These are the two guys who got the Nobel Prize on discovery of graphene. We also got fascinated to prepare some graphene-based compound, but the problem is the graphene has no considerable bond surface. So we adopted a very simple route. We took graphite as a starting material because its cost is very less, 50 rupees per kg, and then we convert it into graphene oxide, and finally we treated different organic amines to transplanting. So you can see that this graphene oxide functionalizes diaminoprotein. They have very high efficiency even at 25 ppm concentration. Plant extract, different parts of the plant. We have studied various parts of the plant like leaf, root, stem, and tested them in iron. Very good performance by these plants. This is also a very serious problem. Corrosion of rebar steel in what we call concrete environment. When rust formation takes place in the steel, It occupies 20 times the volume more than iron and 5,000 psi pressure. So because of this, the whole building structure can be challenged. So lot of precautions is required to prevent corrosion in this environment. We have used calcium stearate at 5 ppm, 5%, and we got, you can see this corroded steel. Food container skin also undergoes corrosion in presence of juices like citric, mango juice, pineapple, orange. We have used glycinate inhibitor and corrosion. Volatile corrosion inhibitors, they are used for corrosion protection of metallic articles like military weapons, electronics. So commercial inhibitors, they are specific for copper, or they can be used for iron. But we developed a new inhibitor that protects all the metals by using copper. It's also used glucagon as corrosion inhibitor in the corrosion conducive process entails the quality of environment, efficiency of infrastructure, green and sustainable approach is the best way to control corrosion, minimizing the economic losses and extending the life. Also recommended for corrosion in the surface. Highly cited and I in fact more than 6 impact corrosion. Thank you very much for your time. Hello? Hello? Hello?
Hello. Thank you so much, sir.
Oh, thank you.
It's our huge honor to listen to the words of wisdom and to grace our program by sharing your deepest knowledge with us. Thank you so much, sir. We have just heard the session from Professor Rami Qureshi, Chair Professor, King Fahd University of Petroleum and Minerals, Kingdom of Saudi Arabia. Thank you so much, sir, once again. Now, proceeding further to our session, we are very much grateful to Professor Shyam Sudhir Pandey sir to give his consent to grace our webinar. I heartily welcome and invite our next distinguished keynote speaker, Professor Shyam Sudhir Pandey sir, to add glory to the session. Before he starts, I would just like to give you a brief introduction about Professor Pandey. Professor Pandey was born in the year 1967 in the Kushinagar district of Uttar Pradesh, India, and completed his PhD from National Physical Laboratory, NPL, New Delhi. In the year 1997, in the area of synthesis, characterization, and application of organic conjugated polymers. He came to Japan as postdoctoral fellow in the year 1998. He worked as Fukuoka Industry Science and Institute-sponsored postdoctoral fellow in the Kyushu Institute of Technology from 1998 to 2001 in the area of photo-functional materials and devices. He was Japan Society for Promotion of Science postdoctoral fellow from 2001 to 2003 for soft actuators and artificial muscles, and Knowledge Cluster invited researcher from 2003 to 2007. Protein biochips. He has received National Technology Award from National Research Development Corporation, Government of India in the year 2005 for the development of glucose biosensors, which is currently being manufactured and marketed by Pulsatum Healthcare Limited, Bangalore, India. He worked in Kyushu Institute of Technology as assistant professor from 2009 to 2012 in the area of design and development of novel photo-functional materials for their applications in the area of next-generation solar cells. Currently, he is an associate professor of Graduate School of Life Science and Systems Engineering, Kyushu Institute of Technology since 2012. He has published more than 190 papers in international refereed journals, about 450 papers in domestic international conferences, and about 30 patents in India, Japan, Europe, and United States of America. His research interests deal with the dye-sensitized and organic solar cells, quantum chemical calculations, organic electronics and optoelectronics, organic conducting polymers, biosensors, and protein biochips. So, today his topic for our session is learning from nature and shaking hands with engineering towards the solution of intriguing futuristic energy problems, which seems to be damn interesting. And we once again heartily welcome and invite Professor Shyam Sudhir Pandey sir, Department of Life Science and System Engineering, Kyushu Institute of Technology, Japan. We welcome sir.
Thank you very much. Okay,
Thank you, sir.
let me try to share. I very rarely use this Google Meet. I normally use Zoom. So this is first time for me, the Google Meet. Let me try I have to share entire screen, right?
Right, sir.
So, and then with the entire screen share, and then okay, let me see. Okay, and then presenting to everyone. I have to minimize this. Can you see my presentation?
Not now, sir. It is not visible right now.
Just a moment. So that's why I always feel little bit problem.
No
Okay.
issue, sir. We are happy to assist you, sir. If you find any sort of difficulty, we will let you.
That I am trying to. It is showing you are presenting here, but I could not get.
So first of all, you minimize your screen and then share it, your PowerPoint presentations.
Okay, just a moment. So first I have to minimize. Okay, let me go. Now this is a screen. It is showing that. Okay, you are presenting to everyone. Then I have to minimize this screen. Is it?
Yes, sir. So first of all, you minimize your screen and then open your PowerPoint presentation.
Okay, just a moment. So I will minimize this screen. And then I open my PowerPoint presentation. And that I opened, but it is showing stop sharing. Oh, no. This problem I always face. Okay, present now. Entire screen. And then share. I shared also, but I don't know why it is not taking. Can somebody tell me? I feel some problem in sharing.
So there is an icon at the top right side of your screen. You have to click on that.
Right side of my screen.
Yes, sir.
On top.
Yes, sir. And then minimize it.
Oh, no. Presenting you. Oh, sorry. It is something very strange window is coming. I don't understand. No. I can't see. What to do? No.
Hello. So,
Yes.
sir, please, you just minimize your window which is opening right now, and just go to your PowerPoint presentation. It will
Okay.
be visible to all.
Now I came to my PowerPoint presentation.
Okay.
But can you see?
So, but we are not able to see it actually.
So that's why I am saying, where is the problem? Because here in my screen it is showing you are presenting to everyone. And yes, this I don't understand the reason that what to do. And when I am going to seeing the PowerPoint, okay, once more I will do the open PowerPoint once I continue. And this is full screen also.
Hello.
Yes, can you see?
So, still it is not visible actually. So, you
Still
just
it is not.
minimize your screen and open the PowerPoint without making any changes to the screen. It will be visible to all.
Okay, just a moment. So now I opened this.
You just first get your screen minimized first.
Where is this screen minimized?
So
It means
yes, your screen is having at the extreme right three icons. The first one is having a minus sign. You will have to click on that. Then your screen will be dropped down. It will get minimized, and then you have to share your screen for PowerPoint presentation.
just a moment. I am just showing the extreme right. Where my picture is there? Right side?
Otherwise, sir, you can do one thing, that you just press the escape button on the keyboard at extreme left, top extreme left.
Top extreme left.
Yes.
Top
Of your
extreme.
keyboard, it is
Okay.
ESC. That is the
Yes,
escape button.
that I did. That I did. But
And then a minimize icon will be displayed at the screen at the right side of the corner of the screen.
right bottom.
No, sir, right top of the
Right top.
screen.
Minimize.
Yes, sir.
No, that I cannot see.
This is actually, it looks like this icon looks like a minus sign, negative sign, like a hyphen.
No, I cannot get. Just a moment. This is screen, then another is only open. This now current screen is there where I am watching everybody,
Yes.
and it is showing my window. You are presenting to everyone. So from this window, what I should do?
So from this actually, because since you are visible to all, you will have to minimize it. Then you have to show your PowerPoint presentation. Only then it will be visible to all the members who are joined with us right now.
So that I am searching where to minimize.
So where we can see the address bar, na, just go to the right of that address bar. There you will see the icon.
Right up. This is like meetgoogle.com.
No, sir. It is having only three icons. First one is the minimize, and then maximize, and then cross the screen, where we can close the screen. So the first icon refers to minimize.
A minus sign. So this I have to minimize.
Exactly, sir. And then you will have to open your PowerPoint presentation.
So I have already opened my PowerPoint presentation.
So you will have to do it once more.
Okay. Just a moment. Okay, I am reopening. Okay, can you see it? No?
Not now, sir.
This I am saying. if I minimize this and I open my PowerPoint also, and still you cannot see it. That's why I wanted in the beginning to test. And here it is saying stop sharing. So suppose if I stop sharing, okay, I will try once again. So now I stop shared, and then I show present now, and I have to select the entire screen. And I clicked on the entire screen and share as well. But okay, now it is showing you are presenting your screen. But this is not being presented. And even if I minimize, I opened my. Can I try to restart my computer once again?
So
And
so otherwise you can do one thing. You just disconnect this meet and
Hmm.
rejoin, and then we will tell you the steps
Okay.
in detail. Okay, sir. You just disconnect first and then rejoin the meet. Due to some technical issues, we are having bit delay in the session. Just within few minutes, Dr. Shyam S. Pandey sir will be get connected with us. So please stay tuned with us.
Okay. Any-
Hello.
Yes. Hello.
Hello. Yes, sir.
No. So again, I am doing and facing the same problem.
Okay, sir. So can you do one thing that can you email that PowerPoint presentation to us so that we can display over here?
Okay. Just a moment, please. 1 minute.
Okay, sir.
Hello. What's Basi? हाँ. चलिए एक बार देखता हूं क्योंकि बड़ी फाइल है मेल से आई नहीं जा पाएगी. Yes. So now I have stopped sharing and then I am clicking the present now. Okay. And then selecting window or entire screen. Okay. Entire screen I selected. And then, yes, there is one window is open. And then share. Okay, that I am doing. So it is showing now that you are presenting your screen. Okay, now I minimized and I opened the PPT. हेलो सर। हाँ यस।
हाँ सर, ये सर आपके व्हाट्सएप पे हमने भेजा है वो आइकॉन। फिर से आप पावर पॉइंट बंद करके फिर से ही अपनी स्क्रीन को शेयर करिए। प्रेजेंट नाउ पे जाइए।
चलिए प्रेजेंट नाउ। पावर पॉइंट ऑलरेडी बंद कर दिए। योर इंटायर स्क्रीन हो गया एंड
आप क्लिक करिए
और इंटायर स्क्रीन शेयर।
हाँ, इंटायर स्क्रीन शेयर कर दीजिए। उसके बाद शेयर कर दीजिए।
ओके,
शेयर कर दीजिए। अब ऊपर जाके मिनिमाइज करिए।
ओके, नाउ आई हैव मिनिमाइज्ड दिस। नाउ आई विल ओपन द पावर पॉइंट।
नहीं, अभी मिनिमाइज कर दीजिए। अच्छे से फिर से मिनिमाइज करिए। अभी मिनिमाइज आपने नहीं किया है। ऊपर जाइए।
जस्ट
क्रॉस का चिन्ह होगा, उसके बगल में एक स्क्वायर ब्रैकेट होगा, उसके बगल में यानी उसके राइट। क्रॉस के राइट स्क्वायर ब्रैकेट के बाद माइनस वाले को दबाइए। जैसे दबाइए वो आप मिनिमाइज हो जाएंगे।
सो मैं तो इन माय कंप्यूटर इट इज शोइंग मिनिमाइज हो चुका है।
मिनिमाइज हो गया। फिर से एक बार क्लिक करिए मिनिमाइज को।
यस, ये तो मिनिमाइज तो हो गया है,
लेकिन मिनिमाइज होने के बाद इधर दिखाई नहीं दे रहा। आपकी स्क्रीन दिखाई देनी चाहिए। आपकी स्क्रीन दिखाई नहीं दे रही है।
तो वही मेरे समझ में नहीं आ रहा कि क्या ऐसा क्यों हो रहा है।
अच्छा, कल किस कंप्यूटर से किया था सर?
कल मैंने अपने घर के कंप्यूटर से किया हुआ था। ये मेरे इंस्टीट्यूट का कहीं फायरवॉल का कोई प्रॉब्लम तो नहीं है?
यस, फायरवॉल परमिशन नहीं दे रहा है सर। फायरवॉल इज नॉट गिविंग परमिशन आपकी वीडियो को आने का, स्क्रीन शेयर करने का। यही दिक्कत है।
जस्ट अ मोमेंट। ओके, सो देन व्हाट आई विल डू कि आप इस बीच में प्लीज ट्राई टू मेक प्रेजेंटेशन बाय समबडी।
He has developed many types of corrosion inhibitors, for example, heterocycles, polymer macrocyclic, dendrimers, functionalized carbohydrates, amino acids, ionic liquids. He has developed first-time graphene-based new class of nanomaterials used as corrosion inhibitors for highly corrosive acidizing environment. Drug and plant extracts for acidizing in sweet corrosion environments encountered in oil gas industry, for which 2 US patents have been granted. He conducted research for more than 35 years in the field of corrosion inhibitors at Aligarh Muslim University and IIT BHU Varanasi. He has been supervised 20 PhD and 30 MTech students. He has published more than 350 research articles in reputed international journals. Currently, he has been cited more than 20,000. He has authored a book on organic heat recycle corrosion inhibitors published by Elsevier in 2020. He has edited a book, Corrosion Inhibitors Science and Technology, published by NACE Houston, USA in 2004. He has received many honors and awards during his service time period. He has served as a founder, head of the Department Chemistry, IIT BHU during 2012 to 2015. I would like to mention a few honors and awards. Lifetime Achievement Awards from Tribhuvan University, Nepal by International Science Congress Association 2015 and National LT Award by National Corrosion Council of India. Third Lifetime Achievement Award of 2020 shall be given to him from Electrochemical Society, Bangalore on January 21st, 2021 at Bangalore. He will also give keynote lecture there. He is currently serving as chair professor from past 3 years at King Fahd University of Petroleum and Minerals, Saudi Arabia. Now, I would like to show you some of the slides on his work.
A.K.S. University
Thank you so much.
So, please wait for another 2 minutes. Our next keynote speaker will be joined soon. Due to some technical issues, we are having some problems to connect with him, as we have to connect from Japan actually. So that's why some technical issues are going there. So we are not able to connect to him right now. Now we are having Dean of Basic Science Department, Professor R.N. Tripathi sir with us for his welcoming and opening remarks on behalf of A.K.S. University. I welcome Dean Basic Science Dr. R.N. Tripathi sir. Over to you, sir.
जी जी ज्वाइन कर लिया सर मैंने।
Thank you so much, sir. So our next distinguished keynote speaker has joined us, Dr. Manish Kumar Dikshit. I warmly welcome Dr. Dikshit to our webinar. He is the National Postdoctoral Fellow at the Department of Metallurgy, Engineering, Material Science, IIT Indore. We welcome you, Dr. Manish Kumar Dikshit, sir.
Thank you.
Thank you so much, sir, for being with us. Over to Dr. Dikshit.
Can you see my presentation now?
Yes, sir.
Okay, thank you. Okay, first of all, thanks to organizing committee for giving me a chance within this reputed society to present my work. My presentation topic is lithium plus mediated low molecular weight anode-oral ligands derived multifunctional metallogels. So the next term which came in our mind is what is gel? So gel is nothing but the self-association of gelator molecules to form long polymer-like fibrous network which further form a matrix that traps the solvent. This process prevents the flow of solvent and mass appears like solids. So this gel material is in between state of this liquid and solid. So based on the origin, it may be of two types: synthetic hair gel, what we used, and natural aloe vera gel, which came out of aloe vera plant. So use of gel related to human life, this hair gel, nail paints, and hydrogel contact lenses. In gel used to record EGC and ultrasound, capsule covers are made of gel. Gel used to collect the blood samples also, and injectable gel could spell relief for arthritis sufferers. So the next question is why we chosen metallo gel for our research work. So the incorporation of metal to the organic gel can add the various additional properties like color, redox, magnetism, optical, morphology, and rheology. Noticeably, the metallo gels are less explored in comparison to organic gels because of difficulty in synthesis, molecular designing, characterization, as well as prediction or establishment of mechanism behind gelation. So our first work dedicated toward charge transfer induced gelation. It was the first ever report over intramolecular charge transfer based metallogels and published in Soft Matter 2016. So this was the molecular designing for this metallogel formation. In this middle part, chiral core taken from tartaric acid, and this was the donor part shown in green, and this has the lone pairs. This was the pi conjugation part, and this was the acceptor part. So what we thought is that this lone pair of electrons should move through this pi conjugation to the acceptor part. From donor to acceptor, this is possible. So seeing this, we designed an orthoisomer of nitro also, where this electron flow was possible from donor to acceptor through this pi bridge to the in both sides. Seeing this, we synthesized another isomer, that is isomer 2, in which nitro group was in or meta position. So in this case, these electron lone pairs were not be able to reach to the nitro group according to our hypothesis, what we proposed. So this is restricting somehow. These lone pairs are not available to nitro group in this isomer, and this is absent in this case. So when we added isomer 2, that is our meta isomer, when we added lithium hydroxide to it, it produces DMSO and acetonitrile solution in presence of lithium hydroxide. Similarly, when we added lithium hydroxide in case of nitro isomer, it produces charge transfer red colored solution in DMSO, while it produces very fascinating metallo gels in case of acetonitrile, which are intensively red colored or pale colored yellow. Similarly, in isomer 3, when we added, it was initially a charge transfer inactive solution. When we added lithium hydroxide, it produces nice red colored charge transfer metallogel. And similarly, when we added lithium hydroxide in acetonitrile solvent also, it forms a intense red colored solution. Further, to prove that it is a gel, not a precipitate, which is holding the surface of glass, we proved through SCM analysis, which is scanning electron microscope. We dried our gel and put it under SCM. So we find that it has a fibrous nature, and this fibrous nature shows that it is metallogel, not a precipitate. Further, we performed UV visible titration using these isomers with lithium hydroxide. In graph A1, we can see that when we are adding lithium hydroxide to this blue line, which is corresponding to ligand, this is disappearing and a new peak at around 400 to 500 region is appearing, which shows that we are getting color in isomer 1 due to this peak conversion. In case of this graph B1, when we are adding lithium hydroxide to blue line, we are again getting a hump around the region of 400 to 500, which is again supporting the phenomena that when we are adding lithium hydroxide to our ortho, we are getting color. But in case of meta isomer, that is C1, when we are adding lithium hydroxide to this blue line, there is no hump available in the region of 400 to 500, which support our physical observation, where we found that when we are adding lithium hydroxide to meta isomer, we didn't find any color, strong color. So these are few properties of metallogel. When we heated it, it is showing thermochromic behavior, and it shows partial self-healing property. When we are disturbing it, it again gains its own shape after some time. So using this UV visible titration, we propose a mechanism for charge transfer, why it is showing color after addition of alkali metal ion to the ligand. So this is the basic strategy of ligand. When we dissolved this ligand in DMSO, it was initially a charge transfer inactive solution. When we added KOH, it becomes red colored solution. This is the proposed molecule after adding KOH. So now the next question arises, is it only K plus who is responsible for color change? Yes, when we added 18 crown 6 to this, which is well-known compound for capturing K plus, this solution turned again into a colorless solution. So which and it form a complex with this potassium form a complex with 18 crown 6, which proves that only K plus is responsible for this color change. So this mechanism is also supported with well performed UV visible titration of 1 plus K plus with 18 crown 6. In figure A, we can see that when we are adding KOH to this ligand, blue line is converted into a red line, which is shown in respective figure also, that colorless solution is converted into a colored solution. Again, when we are adding 18 crown 6 to red solution, it is again this blue line in figure B is converted to its original position, which support our hypothesis that this colorless solution is obtained after addition of 18 crown 6 and K plus is completely removed from the solution. So we proposed a mechanism using all these experiments that this is the ligand representative. When we added metal, it is attached into various functionalities, and these ligands will come close with the help of hydrogen bonding. These hydrogen bonding will come into aggregation, and this aggregation will lead to a single fiber formation, and this fiber will further entrap the solvent and form metallogel, red colored metallogel, which will have a morphology like this. In second case, we took this as a reference molecule. This was having a flexible core. When we replaced OH with NO2 in the last case, we found this molecule which was going to produce a charge transfer metallogel in case of lithium hydroxide, as we shown in the previous slides. Now, when we will delete this flexible core, what will happen? This is a new molecule which was smallest possible symmetrical aromatic gelator reported till date. So when we are adding lithium hydroxide to this molecule, what will happen now? This was isomer 1 for this case. So when we are adding isomer 1, when we are dissolving this isomer in chloroform and methanol mixture, and we are adding lithium hydroxide additionally, it forms a green-blue fluorescent metallogel. Similarly, the para isomer 2, which was designated as isomer 2, when we dissolved this molecule in chloroform methanol mixture, it shows fluorescent precipitate only. No metallogel formation was observed. And now the question arises why this is fluorescent, because it is so small molecule, and when we are adding lithium hydroxide, it is highly fluorescent. So we will see this in later slides. First of all, I will give insights of morphological properties. When we gone for SEM analysis, this metallogel shows fibrous network. This isomer 1, same isomer with sodium hydroxide shows broken morphology. Same isomer with potassium hydroxide shows flower-like crystalline morphology. And when we are adding cesium hydroxide to this same isomer, it is showing normal crystalline morphology. So these are few properties of fluorescent metallogel. When we are sonicating it, dissolution is there, and when we are resting it again, it is again metallogel. When we are heating this metallogel, solvent is evaporated, and when we are again adding solvent, it is again the metallogel is formed. When we are shaking this metallogel, it is disturbed, and when we are resting it, is again metallogel. This shows the reversible properties of this metallogel. When we observe this metallogel under UV light, it was blue fluorescent metallogel. This is the 1H NMR titration. Actually, in this titration, we took our ligand as we can show in Roman first. This is the ligand NMR spectrum. When we are adding lithium hydroxide, this proton corresponding to L-dimine, that's CH protons, and proton corresponding to ortho and meta position of OH are under severe effect. That means during gelation, these are taking part after addition of lithium hydroxide. So through this experiment, we proposed a small model. When we are adding lithium ion to this ligand, it is blue fluorescent metallogel, and we propose that there are stacks which are close to each other and helping in formation of gel. When we are adding little bit bigger size of alkali metal ion, that is Na+, when we are adding this to isomer 1, it is blue, it is fluorescent gelatinous precipitate, not the gel and not the complete precipitate. It was in between state. So we propose that these are the stacks, but these stacks are not close enough to form a gel. When we are adding even bigger size of K+ ion to this molecule, it was non-fluorescent and all the plates are discrete. Similarly, in CS+ cesium ion, same configuration we obtained. So we provided explanation for each case using suitable model that this is our isomer 1 when we are adding lithium hydroxide to it. It produces chef and restricted the rotation around N single bond N. And if we assume this as a plate, this plate will further aggregate, and these aggregates will further stack and will close together and form a fiber-like network, and this fiber will further entrap the solvent and form fluorescent metallogel. In case of isomer 2, that was our para-isomer, when we are adding Li plus N, the electron flow are triggered through Li plus electrostatic interaction with OH, and due to ICT we are getting a fluorescent precipitate in this case. This is the electron movement we are showing through animation. This was the other isomer which we synthesized in this work. This was the meta isomer, and to prove that there is a ICT in this case, in the para case, we synthesized this ligand. When we added lithium hydroxide, there was no ICT possible because these donor electrons cannot move up to the OH group. That is why ICT was absent and non-fluorescent solution was obtained in this case. So this was the crystal structure of our molecule, where we shown the hydrogen bonding between this OH and this N. This is the pi-pi stacking we are showing through a space field model, and this is the distance between two molecules which is in the range of pi-pi stacking. So we proposed a plausible mechanism for this work also, that it is a free lock. When we are adding lithium hydroxide to these locks are closed and chef through chef, and when these molecules are coming close together, they form a fiber, and this fiber entrap the solvent and form a green blue fluorescent metallogel. So this is our third work. And the strategy behind this gelator designing, we designed this molecule based on, we removed this flexible core and replaced it with rigid core, that is benzene ring. And when this metal binding site from this molecule is almost kept similar. So this was the hydrogen bonding acceptor site, chiral center. This was the hydrogen bonding donor site. And this was the hydrophobic core pi-pi stacking, which might be helpful in pi-pi stacking. So these are the two molecules designed in this metallogel synthesis. This was the hydrophilic portion, directional hydrogen bonding, and this was a hydrophobic part, can take part in pi-pi stacking. When we added 3 equivalent of lithium hydroxide for deprotonation, and when we added zinc nitrate in situ, it form a metallogel. And when we added HAuCl4, that is gold solution, we found very interesting AU nanoparticle embedded metallogel without adding any external reducing agent. Under similar condition for this ligand, we found only gelatinous solution. These are few properties of this metallogel. We made it a retractable fan-like shape, which even persistent even after 24 hours, which shows the physical stability of this gel. Similar heating cooling effect are shown in this gel. When we added HAuCl4, it forms AU nanoparticle embedded metallogel, and this metallogel was transparent enough to read through the lattice. When we shake it, it forms sol. Similarly, we gone for TEM analysis of this gel, where we found that long range fibrous morphology for the without AU nanoparticle gel, and when we added AU nanoparticle, these nanoparticles were deposited over the fiber platform only, or maximized growth was only fiber platform. This we will explain in later slides why these nanoparticles are not in the matrix, only over the fiber. So this was the supportive UV visual experiment, that plasmon band was around 500 to 650 region, which shows that AU nanoparticle is synthesized inside metallogel. Structural elucidation, powder XRD analysis. In powder XRD analysis, we can see that this large intensity peaks are there for ligand, which shows that ligand has crystalline nature, but while the metallogel shows amorphous nature because it has no high intensity peaks available in powder XRD pattern. This was the IR analysis. In IR analysis, we can see that the CO stretching frequency for ligand was 1615, but when we formed a metallogel, this CO intensity peak slightly shifted to 1631. But interestingly, when we added gold solution, that is our HAuCl4 solution, this CO intensity, CO stretching frequencies again shifted to its original position. That means in HAuCl4 addition, this gold nanoparticle is somehow assisted. The gold nanoparticle synthesis is somehow assisted with the help of this internal reducing agent, that is CO, available in our molecule. That is why we found the growth of nanoparticle only over these molecular fibers. Fluorescence study we shown, this is the gel dilution experiment, where when we diluted this gel from 10⁻²to 10⁻³ in figure B, we can see that fluorescence intensity is increasing, and further dissolution takes the fluorescence intensity down, which shown that this ACQ and AIE effect, that is aggregation caused quenching and aggregation caused enhanced emission of fluorescence intensity, was there during the gel formation. So possible H and J aggregate for this gel. This is our molecule, representative molecule. When we added lithiated water and zinc to this molecule, it forms H aggregate, which ultimately lead to the gelation. Similarly, in case of other ligand, this is a representative of our second ligand. When we added lithiated water and lithium hydroxide in water and zinc, it form a J aggregate, which is quite different from our first case, and it related to only solution. So coordination polymerization for this case was proven through SIMS analysis, where we found that 1:1 peak was there. And similarly, through Jaws plot under UV visible titration, we found that this is the 1:1 complex unit is present in this molecule, which is responsible for coordination polymerization of this metallogel. So further we performed application part, that is kinetic study of paranitrophenol reduction using our metallogel system. So in figure A, we can see that when we are adding NaBH4, paranitrophenol is converted into paranitrophenolate, and when we given even more than 100 times of NaBH4, this paranitrophenolate is not converting into its amine counterpart. But when we added our metallogel directly in presence of NaBH4, in figure C, we can see that this paranitrophenolate is converting, and it takes only 7 minutes to convert into para-aminophenol. This figure D and figure E are showing is that it is first order rate kinetics, and Eyring, we set this data in Eyring plot, that is ln k by t versus 1 by t. Through this 3 equations and that graphs, we calculated our various physical parameters regarding this, and K apparent was found to be 0.223 minute inverse for gold nanoparticle mediated paranitrophenol reduction, and for CPH, that is in absence of this gold nanoparticle, it was way lower than AuCPH. Similarly, for activation energy and entropy and enthalpy, all Ks are better in AuCPH, and CPH was unable to reduce paranitrophenol in presence of NaBH4. So we proposed a mechanism for AU nanoparticle formation, that how it is forming over nanofiber platform. So this was the proposed hypothesis, and these nanoparticles were further utilized for reduction of 4-nitrophenol, and these nanoparticles were synthesized over nanofiber using this molecular structure. This was the plausible explanation of our AU nanoparticle formation on the fiber surface only, because these molecules are involved in the generation of this AU nanoparticle. That is why these AU nanoparticles are sticked only over nanofiber platform. So this was the plausible mechanism for this molecule. When we added lithium hydroxide and zinc, it formed a network-like structure. When we added this water, it forms a fibrous network, and this fibrous network leads to metallogel formation. And when we added this HAuCl4, that is gold solution, this forms a gold nanoparticle embedded metallogel. So the conclusion for our work was, through our work we discussed various methods for metallogel synthesis and developed the idea about the unusual metallogels can be synthesized by applying the structural modifications. Metallogel synthesis is itself very challenging and interesting. There is no conventional method reported for synthesis due to difficulties in production and control of molecular functionalities towards gelation. However, we developed some skills towards synthesis of metallogel, which has been discussed through our work. Chelation restricts the molecular rotation and provides the platform for molecular stacking, which leads to aggregation and followed by gelation. Charge transfer helps in balance the dipole moment as well as in aggregation of molecules. Extensive network created by coordination polymer helps in trapping the solvent. Metallurgically utilized for in situ nanofabrication of gold nanoparticle synthesis and their nanocatalysis with first ever complete kinetic study. These are few list of publication from my side. And I acknowledge Dr. Miguel Dubé, my mentor, for his continuous guidance and support. I acknowledge DST Inspire for providing funds of our research work. I acknowledge Sebastian Manivali, ENS Lyon from France, and C. Butcher from the same place. I acknowledge IIT BHU for funding of my research and providing me fellowship during my PhD work. I acknowledge SCRB National Postdoc Fellowship. And thank you for your kind attention.
Thank you so much, Dr. Manish Kumar Dikshit, for sharing a valuable knowledge and deepest knowledge with all of us. Thank you so much for being with us, sir. It was a wonderful pleasure to have you in this session. So now we have reconnected with Dr. Shyam Pandey, sir, again.
Okay, thank you very much. And before any problem, let me first just try to share it. And if everything is okay, then whatever you tell, accordingly I will do that.
Okay, sir.
So I am go for presenting and then entire screen and then share screen. And just a moment. It is now showing you are presenting now. And then I have to minimize. Is it okay?
Yes, sir, it is visible now. Perfectly all right, sir.
Okay, so it means now no problem.
Yes,
so what should be done? One idea is that Shailendra ji was saying that one person has to present, after that I should present.
No, sir, you please continue, sir.
Okay. So if no problem, then I would like to continue it, okay? Okay, so just let me make sure. Am I audible? Everybody can listen me?
Yes, sir, you are audible.
Yes.
Okay, let me go to the full screen. Okay. So anyway, thank you very much. And I am really very sorry for inconvenience caused, because I was in my institute and firewall was restricting to share my presentation. So thank you very much for bearing. So well, as introduced before, that today I am going to talk on this. You can see on the title, Learning from the Nature and Shaking Hands with Engineering Towards Solution of Intriguing Futuristic Energy Problems. In this topic, as you can see, first before really going to my talk, a brief introduction about I belongs from Japan, and as you can see on this map, so the south of the Japan is Kyushu Island, and the north part of the Kyushu is known as Kitakyushu. So currently I am located. And my institute is Kyushu Institute of Technology. It has 3 campuses. The first campus was started in 1909, followed by the second campus 1989, where I came in Japan 1998. And finally moved to this third campus, started 2001 in Wakamatsu area. They are separated by around 40 to 45 kilometers from each other. And now this my institute, as you can see in the red circle, is located in the Science and Research Park. And in the Science and Research Park, it has 4 graduate school, research institutions, exchange and academia collaboration, So it has a common goal, like famous institution, Waseda University, Kitakeso University, Fukuoka University, and our institute is located in this whole science and research park. And about my laboratory is organic photofunctional materials and device lab. And the main research theme of my lab is the next generation solar cells. Second theme is organic electronic devices. And the third is the bioimage sensor. In all these three major themes, we work on starting from computer simulation to material development and their device implementation. Before starting the just talk, I like the quotations very much. And one quotation I'd like to share is by Louis Pasteur, that the more I study the nature, the more I stand amazed at the work of the Creator. Science brings men nearer to the God. With this, as we know that we have very good gift from the Mother Nature, like water, wind, light, land, and of course, based on that, the life forms we are. And there is a cooperative existence. In our Hindu philosophy, you can say, mythology, you can say, we have seen that Chitijal Pavak, Gagan Samira, Panch Tattva Tera Cha Sarira. So these non-living objects and living objects, they live cooperatively. And one of example of the cooperative existence is the two phenomena. And this is for the students, like plants and living being, like animals, we. Two phenomena, photosynthesis and respiration. They are a burning example of the coexistence, cooperative existence, where plants, they take carbon dioxide, emit oxygen in the process of photosynthesis. On the other hand, we need that oxygen and produce carbon dioxide by the process of respiration. So today, and this will be very much related to my talk also, so later on you will see the connectivity. My talk will be going on through these four topics. And first, in the initial topic, like in front of us, there are many problems, as mentioned here. This was very well quoted and discussed by Professor Richard Ismaili, a Nobel laureate. And amongst these problems, energy and populations, they are very closely related, because the world population is increasing, standard of life is increasing, means we need more and more energy. So energy is a big futuristic problem. How I am going to discuss. But for the students, in front of us, the challenge of energy for us, for our sustenance, is the terawatt challenge. To give a very simple example, like a laptop we use by 1 watt, a toaster we take a breakfast, use kilowatt, airplane megawatt, by nuclear reactor we produce gigawatt, and we need on this earth terawatt. Currently 15 to 16 terawatt energy is needed. This challenging energy demand, if we see, 85% is coming from the fossil fuels, oil, gas, coal. They are very precious, non-renewable. Less than 10% is only by the nuclear and renewable energy. On the other hand, this fossil fuels continuous use is creating global warming. This has been now scientifically proven also. In less than 100 years, temperature has increased around 1.5 to 2 degrees Celsius. And at geographical scale.
Sorry to interrupt you, sir. Your PowerPoint presentation is not visible to all of us.
Oh, really?
Yes, sir. Just now it has not visible.
Let me try one.
Okay, sir. No issue.
But before it was visible?
Yes, sir. Earlier it was visible, right?
Okay, what happened? Let me do one thing. Okay. Let me see, present now.
Yes.
Once again, I will try.
Okay, sir.
Share. So please tell me in between if such problem happens. I don't know why it happened.
Okay, sir. Definitely, sir.
And just a moment. So then minimize. Is it okay?
Yes, sir. Now it's fine.
Okay. Thank you. Thank you very much.
Okay, sir. No, my pleasure, sir. Please continue, sir.
Okay, thank you.
Thanks, sir.
Okay, so I was talking about that, of course, the global warming is presently scientifically proven, and amongst the fossil fuels, oil is the biggest, richest source of our present day energy. And this oil was expected to have a peak by 2016, but in between shale oil and oil sands were discovered and peak went to 2037, and that is expected to be finished by 2080. So the question is, what to do next? Because we cannot depend on the fossil fuel if we think beyond 2100. The energy gap, currently we are using 15 to 16 terawatt, and by 2050 we need around 32 terawatt. So there will be gap of around 14 to 15 terawatt, which will increase by 33 terawatt in 2100. So the question is, from where this huge energy will come? Fossil fuels are going to finish, and even if we are blindly using, they are creating greenhouse emission. So renewable is one chance. Now the question is, can we get sufficient amounts from the renewable energy? Calculation says that if we use biomass completely burn, we can get maximum 5 to 7 terawatt. Hydroelectricity 1.2 terawatt, geothermal 1.9 terawatt, tide ocean 0.7 terawatt, and wind 14 terawatt. Even if we combine all these renewables, it cannot cover up 33 terawatt gap. Remaining is the solar energy, 10 to the power 5 terawatt on the Earth's surface. Huge energy is available. How much huge this is? In 1 hour, sun emits 14 terawatt. What we are currently using in 1 year. Sun has such a huge source of energy. A calculation indicates that if we use the 10% efficient solar cell, now commercial solar cell are 15 to 16%. So I'm saying approximate 10% solar cell and cover it 0.16% of this Earth. Means only by solar cell covering 0.16%. That is a part of desert only. We have capability to get 20 terawatt power. Otherwise, we have to create 20,000 1 gigawatt nuclear reactor. It means one nuclear reactor every day for 50 years. And we know how much dangerous it is. Accident of Chernobyl and very recent Fukushima, Japan has witnessed to shut down that even meltdown Fukushima plant. It is going to take more than 20 years to completely shut down. So we cannot depend on the nuclear energy. This is a temporary solution and dangerous solution. And the good hope is the solar energy. That singularly is capable to solve all our energy needs. But every coins, the both sides are not same glittering, just like a painting. One side is very beautiful, the other side is so ugly. The solar cell. Energy is huge, but density, 1000 watt per meter square, means 100 milliwatt per centimeter square. Example shown here, if we make a solar panel of 1 meter by 1 meter, and if it is 10% efficiency, it means 100 watt. The take home message is solar energy is good, but energy density is not that much high. We need to implement a large area. Even if you see the scenario of energy, the solar cell creating electricity covers only 2% of the total energy what we are needing currently. Why this is? Because of the cost. If you see the electricity production cost by the coal, oil, gas, 1 to 5 cents. On the other hand, 25 to 50 cents by the solar cell. Means current technology, raw material, causing solar cells production cost 10 to 20 times higher as compared to conventional fossil fuel. This is the reason we are still dependent on the fossil fuel. To use the solar energy, which is must for our future, this solar cell has to become cheaper. If you see the champion, if you see a solar cell efficiency data of the commercialized silicon-based solar cell, efficiency is high. But because of cost, the next generation solar cells like dye-sensitized solar cell, polymer solar cell, perovskite solar cells, they are coming into the picture. What is the idea behind the next generation solar cell? The idea is to use the cheap raw material, not to use very high temperature process, clean room process, like silicon solar cell. Otherwise, we cannot make it cheaper. So, we found that huge energy is needed for the future. Solar cell has a capability to solve our energy needs. And next generation solar cells are needed to make the solar cell cheaper so that we can implement large area. And amongst next generation solar cell, one kind of solar cell is dye-sensitized solar cell. Before going to dye-sensitized solar cell, many students might be listening. I want to see their attention, gather their attention that they have studied the photosynthesis in their high school days. And there, in photosynthesis, light energy is converted into chemical energy, and leaf you can consider as a kitchen. This is the old story. You all are university students. So this idea is that in photosynthesis, these colored molecules, chlorophyll, green pigments, they capture the light. They convert light energy into the chemical energy. The beauty, the famous G scheme of the light and dark reaction, where the light energy is converted into the chemical energy, is shown here. What is the beauty? The beauty is division of labor. In nature, the work is divided. The colored molecule, they have only duty to absorb the light and excite the electron. And then to tunnel the electron, different electron transport chains are available. So duty is divided. The division of labor, one of the most beautiful aspects of the nature. So the photoexcitation and electron transport, they are taken by different entities, different bodies. Work is divided. If we use this concept, division of labor, and use in a solar cell, of course, that will be a good idea. And that came into the dye-sensitized solar cell. This kind of solar cell is basically use the colored molecules to absorb light and produce electricity. This kind of solar cell inspired from the photosynthesis. were using colored molecule to absorb light and uses concept of electricity, electrochemistry. And on these two principles, this kind of solar cell works. Although this solar cell was discovered long back in 70s by German and Japanese scientists, but efficiency in 80s, it was less than 1%. Later on, nanotechnology came into the picture and efficiency of 7% was demonstrated. Then this kind of solar cell came into the limelight and considered to be as electrochemical solar cells. How to make the solar cell? You need simple, a suitable dye, colored molecule, just like a green chlorophyll. You need electron acceptor. You need hole acceptor and you need electrodes. Concept is very simple. The dye molecules absorb light. They boost electron to excited state. And now there is one electron acceptor, one hole acceptor. And then we use the electrodes for extracting hole and electron. And our solar cell is ready. So now the division of labor is here. The colored molecules are there to absorb the light. For electron accepting and hole accepting, other species are there. And since electron and hole acceptor are transparent, they have no color. So the color of the solar cell is the color of the colored molecule dye. So this kind of solar cell are transparent, colorful, beautiful. No need only on the rooftop. You can make in the windows of the house. And Toyota is working here in Japan very well to make like a Toyota dream house project. As you can see in photo, there are many photosynthetic pigments. They are being used, colored molecules being used in the photosynthesis. So we have a huge variety of natural dyes. Flowers, leaves, roots, fruits. We can get colored molecule. And we can use them to tap electricity. Means there is further possibility to make cheaper solar cells. The device architecture is very simple. As you can see, we need one electrode, transparent conducting glass. Onto that, we coat titanium dioxide nanoparticle as electron acceptor, which is coated with the dye monolayer of the dye molecule. We put electrolyte as our whole transport material and counter electrode. Conducting, you can take conducting glass or any metal. And your solar cell is ready. Working principle is very simple. You shine the light, dye molecule excited from their ground state to excited state, tunnel through the electron acceptor, goes to the external circuitry, and oxidized dye molecules are generated from the electrons coming from the external circuitry via the redox reaction of the electrolyte. So mechanism is very simple. Another, how to make it? Very simple. You take a conducting glass, you can make titanium dioxide nanoparticle, make a ink, paint, print it. Just heat in a furnace at 450 degrees Celsius to remove the binders and resin, to remaining only electron acceptor on conducting glass. Put in a dye solution, monolayer of dye molecules are absorbed. Get the counter electrode, seal it together, add electrolyte or whole transporter, your solar cell is ready. Very simple process. In silicon solar cell, you need a clean room. That you call the fab. In normal condition, you cannot make even 1% solar cell. In a very common room, you can make this kind of solar cell 7 or 8% very easily. This is only because of division of labor concept is working here. That was nature inspired. In the last 15-20 years, as you can see, these using dye sensitized solar cells, they have reached efficiency more than amorphous silicon between 11 to 14%. Amorphous silicon is around 10%. Crystalline silicon 20%. Now, so that what
The take-home message is, using dye-sensitized solar cell, we can make solar cell very simply using the cheap raw material with the simple process. Now the question is, we have efficiency around 10 to 14%. Why? Because if you see, the potential dies by 11 to 14%, they absorb mainly in the visible region of the spectra, means solar spectrum. It means, because other region beyond 700 or 750 nanometer, there is no light absorption, because currently what dye we have used. So the idea is, we can use the NIR dye. And that has been shown. This is a practically achievable efficiency. Using a visible dye up to 800 nanometer, we can get efficiency 14 to 15%. What has already been achieved? Using same state of art, if we can develop an NIR dye with 900 nanometer 18% efficiency and 1000 nanometer 20% efficiency, is practically achievable. So the question is, now we have technology, we have the know-how. What is not we have? We don't have suitable NIR dye. If somebody can develop, certainly such efficiency is achievable, which is needed, or you can say a bottleneck for commercialization. Of course, all colored molecules cannot be used. They have to fulfill some criteria. The conduction band of the dye should be higher than the electron acceptor, and the valence band of the dye should be lower than the redox energy level of whole transporter. This is one requirement. Another, there should be sufficient electronic coupling between the electron acceptor molecule. Means there should be sufficient electron density at the conduction excited state of the dye molecule. If these criteria are fulfilled, the dye will work. For example, this dye gives 12% efficiency. If you see, this to make this, chemist knows it takes a hard time, 10-15 step synthesis, 2 to 3 months time. Now the science has become modular. We do computational chemistry. In advance, we predict where electron density is okay in excited state, energetically it is favorable or not. And Gaussian is one of the very nice program worldwide being used. For example, this is one molecule. As you can see, this is the main dye body, and this is anchoring group by which it attaches to the electron acceptor like TiO2 nanoparticle. I calculated them, and if you see the distribution in valence band, the electron density is mainly towards this main body, main framework. On the other hand, in excited state, it is electron density at anchoring group. It means, and this is the site of binding. So it means electron can be very easily tunneled, jumped, injected. And this shift of electron density from valence to conduction is known as intramolecular charge transfer. So by computer we know, and we know energetically also, the conduction band of this dye is higher than TiO2. The valence band of the dye is lower than redox electrolyte. Means energetically this is favorable. And that's why this dye works and gives efficiency around 7%. It means now computational technology is very advanced. But in computational technology, as you know, many of the students, you know, that to get the exact energy and spectra, we need the solution of Schrödinger wave equation. You know how difficult it is to solve single hydrogen molecule ion. In your MSc courses you might have done, it is so difficult. So it is very difficult to solve by human brain with the multi-atomic, multi-electronic system. For example, this is very simple molecule, methyl cyclohexane. Please tell me when time I reach half time, so that I can minimize, because I am not taking care of the time right now. So this molecule for means computational structural means structural optimization. If you see, when the calculation level was STO3G here, it takes 10 seconds to get the exact 3D structure. When it went to here, 6311G DP, it takes 10 hours. Actual Schrodinger wave equation is here. Means we have to make a logical compromise. How much computational power do we have? How much time do we have? How much accuracy do we need? Using one of the model NIRDI, we demonstrated that using an appropriate algorithm during theoretical calculation, quantum chemical calculation, we get the different result. And for example, using LSDA, RB3PW91, get results very closer to the experimental value. Excited by these computational calculation, one target what we obtained is that to get how much minimum energy is needed for electron injection. We designed several molecules. We synthesized in the lab. We made a solar cell. And we shown that even this minimum gap of titanium dioxide conduction band and excited state energy level of this dye, 0.15 electron volt is okay. That it harvests, it works as a solar cell. So minimum energy is needed 0.15 electron volt. Same, we designed different molecule. Now our target was to get how much minimum energy is needed to regenerate them, to get electron to reoxidize the excited dye molecule. And we proved that it needs 0.12 electron volt. So for regeneration, 0.1 electron volt minimum is needed. For injection, 0.15 electron volt is needed. Now, so what is message? If we combine these two offsets, delta G1 and delta G2, it is coming to be 1.17 electron volt. Means, and if we convert into the wavelength, it comes 1060 nanometer. It means we can design an IRDI until 1060 nanometer to make DSSC. This gives theoretically achievable efficiency around 28%. So these calculations suggest that there is a chance further by developing a novel NIR dyes, it is possible. Now the question is, another question is that how to get the high efficiency. With the visible dye already 10 to 14% has been achieved. Our idea is to develop an IR dye. Even 5% is there. Commercial, please keep in mind that commercial target is 15%. So if we have 10% of this dye, we develop an IR dye 5%, we combine them together, we can cross the barrier of 15%. Based on that, we can use these two dyes in tandem and hybrid device architecture to show that feasibility, whether can be used the two dyes. For example, we have shown here, this is one commercial dye, orange color dye D35. It absorbs in 400 to 550 nanometer. Then in our lab, we designed another blue dye. As you can see, absorbs between 500 and 700 nanometer. Energetically, they are matching both of the dyes. And we try to make the solar cell. Because this solar cell, this orange dye makes only 2 to 3%. Maximum 4%. This blue dye makes 2 to 3%. So what we can get, the maximum, if we combine, if they work very synergistically, in that case, we can get 4 to 6%, maximum 6% we can get. By combining, if the both of the dye, they work individually. I'd like to focus here and show here, in mathematics, 1 plus 1 is 2. But in science and philosophy, 1 plus 1 is not necessarily 2, always 2. It may be greater than 2, it may be less than 2. Greater than 2 in philosophy is success. Less than 2, 1 plus 1 is failure. On the other hand, in science also, we call catalysis or synergistic effect. using the two components, sometime we get better performance. And we demonstrated here, as you can see here, by changing the ratio of these orange and yellow dye. Even when ratio as 1:4, efficiency 2.53% lower than individual one. On the other hand, when ratio is 4:1, it is 7.2%. That's why I told that it is possible in science to get synergistic either activation, sometime deactivation or poisoning also. Recently, this is one of our recent green dye developed by our group, and we have just submitted this to American Chemical Society. And this gives efficiency of 6%, mainly in the, you can say, far red to NIR region. And we are trying to couple this with the efficient visible dyes to achieve the target beyond 15%. Now, how much time do I have? Hello? Is it okay to continue? Okay, no response. Anyway, let me go through it. So now as the last topic, that is the remaining challenges and some of the probable solution. If we see that dye-sensitized solar cell as industrial perspective, it has been shown that DSSCs are stable, we can use for the 10 years. The current silicon solar cells, they are up to 20 years. So what is needed? It is needed to increase the efficiency and to increase the stability, to decrease the cost also further. Three targets are there before industrialization. Now, to make it more cheaper, what we can do, we have to think about cost controlling factors. And if possible, it is better to remove the costly component. And if we see, the material cost is 69%. Sealing cost, next, and in this material cost, there is a sealing, TiO2 dye and other material. And please see, in material cost, the TCO cost, means transparent conducting glass, 17%. And estimation suggests, if you do the large scale production from 1 megawatt per year to 4 megawatt per year, other cost decreases, but the transparent conducting glass, TCO cost increases. Running cost decreases. Means, transparent conducting glass is one of the costly component. So, how to remove that? So, the idea is, can we make a TCO less dye-sensitized solar cell? One suggestion was done by the different scientific group. They said, okay, this side is transparent conducting glass is needed because we coat the TiO2 and electrons goes outside. This side we can use a titanium or metal sheet. But we proposed another design. We called back contact dye-sensitized solar cell, where you use normal glass with titanium dioxide nanoparticle, and backside we coat the thick titanium metal. And this is another titanium sheet. So this is completely TCO less back contact dye-sensitized solar cell device architecture. And we shown that the transparent conducting glass has a sheet resistivity of around 10 ohm per centimeter. When we calculated the titanium metals, if we increase the thickness, the sheet resistance comes more down. Even up to 500-600 nanometer, around 0.5 micron, 0.6 micron of titanium, we can get sheet resistance even lower than transparent conducting glass. So we become very happy. Okay, so we can get good fill factor also. And we made a solar cell by this device architecture we proposed. But the result was horrible. When we increased the titanium thickness, the efficiency became down. As you can see, we were thinking a positive result, that increasing the thickness, heat resistance will decrease and will get better efficiency. Result was just opposite. That was surprised us. So then we thought, what is the problem? By coating a thicker titanium layer, its current collection is okay. But our to get the redox reaction, the ion has to pass through this dye molecule for regeneration. This block. So dense layer was blocking ion diffusion. And that is the reason efficiency was going down. So we got the answer for the problem. But the question is, how to solve this? जो इंडिया में कहा जाता है कि बिल्ली के गले में घंटी बांध दी जाए तो चूहों को पता चल जाएगा, लेकिन वो घंटी कैसे बंधेगी और कौन बांधेगा? That was challenging question. We tried to solve this, and the answer was came by tetrapodic zinc oxide. This was we called Panatetra. This special zinc oxide came from the Panasonic company. We use this to solve this problem. You can say how. The idea was very simple. We did the TiO2 coating. Onto that, we sprayed the tetrapodic zinc oxide. Since it is tetrapodic, and then we deposited dense zinc, titanium metal. Since it is tetrapodic, so it cannot completely cover. Then we put in HCl solution, and you know TiO2 has no reaction, but zinc oxide dissolved. It created a straight pore for ion diffusion. That idea worked very well to get straight pore with the titanium metal. And now you can see, after increasing the titanium thickness, efficiency was completely, that problem was solved, and we got nearly same, sometimes little bit better efficiency than using TCO glass. And that we patented as well. Later on, we demonstrated using complete TCO-less 8% efficiency dye-sensitized solar cell. But the process, as you can see here, is quite complicated. Industrially not that much viable. So we produced another idea that how to, before such concept was patent was there by Hitachi Maxell, to use on the plastic substrate dye-sensitized solar cell, or flexible substrate basically. But efficiency was very low, especially 1.5%. We tried to find it out. Why efficiency is low? Because when we use the stainless steel and then we coat TiO2 and dye, there was electronic recombination. And this recombination, because of back electron transfer, was a problem. So how to solve it? We tried to do it, okay. Let us make a compact TiO2 layer on the coating of the stainless steel mesh. And when we heated, it was a cracking. And the cracking was because of coefficient of thermal expansion of TiO2 and stainless steel was different. So that was the big problem. Then we proposed another idea. That idea was the gradient TiO(X) layer, like TiO 0.5, TiO1, TiO 1.5, and TiO2 by arc plasma method. And that was really successful. You can see here, by gradient TiO2 layer on the stainless steel mesh, there was no cracking. And that the idea is very simple. We take stainless steel mesh, we put the gradient TiO(X) layer as a back charge recombination blocking layer, then TiO2 nanoparticle, and then dye. Then we assembled the cell, and as you can see here, that efficiency was increased. Initially, what was patented 1.5%, we got more than, started from the 2%, then dense 2.8% and went up to 5%. So this idea was working very well. And the best efficiency with the completely flexible, we demonstrated 5.56%. Then we shown that when you go to bigger, large area, because it was metal based, so seat resistance was not creating a problem. If you go for large area in the means transparent conducting oxide, the efficiency decreases. On the other hand, in our case, TCO-less efficiency was no problem. Using this flexible metal stainless steel mesh-based flexible anode, we created different device architecture, the fiber, the tandem, the hybrid, and the cylindrical, different device architecture we demonstrated, published, and patented. This can make like a roll-to-rail process also possible, that we can make a different seats, metal seats, die coating, top seat, and we can laminate, and this can give industrially viable fabrication of die-sensitized solar cell. At this moment, I would like to acknowledge our group head, Professor Hayase, present and past members of our lab, and supports from the scientific research, grant in aid of scientific research of Ministry of Science and Culture and Education. And I would like to thank you for your kind attention. Thank you very much.
Thank you so much, sir. It was really an extraordinary topic full of rich words connected with nature. A really remarkable lecture by you, and thank you once again for sharing your profound knowledge with all of us. Thank you so much, Pandit sir. Now, our next distinguished keynote speaker for today's session is Professor Vijay Kumar Agrawal. Professor Vijay Kumar Agrawal is the director at NITTR, that is National Institute of Technical Teachers Training and Research at Bhopal, and professor at the Department of Chemistry of Desh Pratap Singh University, Rewa. With the long list of his achievements and glory, I would like to invite and warmly welcome Professor Agrawal, and he will put light on the topic chemistry and human health. May I request Professor Agrawal to join us and proceed further. Over to Dr. Agrawal.
Thank you very much, organizers, for giving me an opportunity to be here. Especially I'm thankful to A.K.S. University and Professor Neelam Richaria for inviting me and giving me opportunity to present the topic which relates to chemistry and the human health. So it is a kind of popular lecture. I am not going to discuss the research which I am doing in the field of computer-aided drug discovery, because I thought that since this is going to be a program for students as well as new faculty members, so one should understand what is the contribution of chemistry, and especially in the area of human health. So can I share my slides, please?
Sure, sir.
Visible? Is it visible?
Not now, sir.
Not now. How to share it? I have to minimize the. Okay.
So you have to click on the present now.
I have to click
at the left.
At the left.
Present now. A small icon is there. You have to click on that. It will
circular. Talk to.
So a small icon at the left of your screen, bottom left.
Bottom left. Meeting details. No.
So extreme right at the bottom. It is present now. You have to click on that,
Present now. Okay.
and then you will have to minimize your screen and open your PowerPoint presentation. So have you clicked on the present now?
I think my screen is visible.
Not now, sir.
Not now. Okay.
So again, click on present now,
Just
and then
wait.
share entire screen.
Present now.
Then share entire screen.
Your entire screen.
Right, sir. And
okay, and then my PowerPoint. Is it visible now?
Still it is not visible, sir.
Not visible. Share your.
Well, you will.
Okay, I'll do that. Okay, share your. Why it's not coming?
So you have to go to present now, then click on the entire screen, and then a window will come. You will have to click on that and minimize the window, and then you have to open your PowerPoint presentation. Then it will be visible to all of us.
हाँ शरण जी.
और शर्मा जी ठीक हैं?
मैं ठीक हूँ. मेरे बड़े भाई साहब को मैं प्रणाम करता हूँ. नमस्कार.
नमस्कार नमस्कार. कैसे हैं? बढ़िया.
मैं एकदम ठीक ठाक हूँ सर. आपका लेक्चर सुनने के लिए यूनिवर्सिटी से भगा भगा आया हूँ अभी घर पे.
अरे मैं भी यूनिवर्सिटी में फायरवॉल की वजह से मैं नहीं हो पाया था, तो इस वजह से
मुझे फिर प्रॉब्लम हुआ था. मैं देख रहा था.
चलिए, बड़ा अच्छा लगा है काफी दिन के बाद फिर.
हाँ,
ऑनलाइन ही मिला.
पैसा और ठीक ठाक है ना?
सब कुछ बहुत बढ़िया, सब कुछ कुशल मंगल है.
और बाकी सब कुछ नॉर्मल हो जाएगा तो आपसे मैं कांटेक्ट करूंगा फिर.
जरूर जरूर जरूर. हाँ चलिए, इन्होंने शेयर कर लिए, इनका सुनते हैं.
हाँ हाँ.
ओके
ओके ओके. नमस्कार सर.
Agrawal sir, your mic is not on actually. Please switch on your microphone. You are not audible to us, sir. Now it's fine.
Now I'm audible.
Yes, sir. Now it's perfectly all right, sir.
So the topic of my presentation is chemistry and human health. I'm trying to discuss some of the important contributions of chemistry, how chemistry changed the entire society and human life. Now, if we go from our ancient period, we understand that it was the fire which was learned first. Then after the fire age, then we came to the human society where livelihood was important, and then we discovered the elements, then the state of matter, solid, liquid and gas, then gravitational forces were discovered, then Newtonian laws of motion, and of course chemicals and periodic table. Our ancient system also tells us about the Ayurveda, how the plants are used in the treatment of ailments. So all the vegetable available in the earth is treated as medicine. So there is a Sangita, Sushruta Sangita, which says about the Ayurveda. So the discovery of natural trees, then cinchona and natural products come into existence, and they were used as medicines. And then the environment was considered, and how to protect our environment. Then chemicals were identified, which chemicals are hazardous chemical, which are toxic, how we can develop new material to protect our environment, how the chemicals, identified chemicals can improve the human life, whether it is a form of drug or it is a form of nutrients like that. So there were many chemicals which were recognized as good for the fertilizer.
Sorry to interrupt you, sir. Please press F5 so that your screen will be maximized. Yes, sir. Now it's fine. Thank you, sir.
So with the knowledge of the chemicals which were improving of the soil, they were used in agriculture, they were used as fertilizers, they were used as pesticides, they were used as herbicides. Then the knowledge of the chemical test, how the glucose is tested in the laboratory, and that method was used for the diagnosis of the ailments, the diseases. Knowledge of X-ray, we know that the X-ray is very common nowadays. When you have some a brain injury or a bone injury, then you go for X-ray. The technique of NMR is very much useful now in CT scanning and the nuclear magnetic resonance imagery. Then MRI is important. So these research in drug discovery is very much helpful in the for the human health, in especially in the diagnostics and prevention of the ailments. Now we face many types of hazards, biological hazards from more than 1,400 pathogens that can infect human body. A pathogen is an organism that can cause disease in another organism, that is bacteria, viruses, parasites, protozoa, fungi. And we also know there are many types of biological hazards. They infect the human body. How they infect the human body? They come through pets, livestock, wild animals, insects, food, water, and air. And these organisms can come and infect our body. When they infect our body, then infectious diseases are there, and they are mainly a threat for the human health. So large-scale outbreak of an infectious disease in an area is called an epidemic, and we are also facing nowadays the corona epidemic, which the entire world is facing. AIDS was one of them. Then many diseases carrying bacteria have developed genetic immunity to widely used antibiotics, and many disease transmitting species of insects such as mosquitoes have become immune to widely used pesticides that once helped to control their population. Now, here is a chart which says that death per year by the 7 deadliest infectious diseases. Now, because of pneumonia, 3.2 million people die every year. HIV/AIDS, 1.8 million. Diarrhea, 1.6 million. Tuberculosis, 1.3 million. Measles, 800,000. Malaria, 780,000. Like that. And now the coronavirus, which obviously is very deadly disease, and the mechanism is still to be discovered, exact mechanism. Now, chemicals can cause cancer, mutations, and birth defects. A toxic chemical is one that can cause temporary or permanent harm or death to human and animals. And in 2004, the EPA listed arsenic, lead, mercury, vinyl chloride used to make PVC plastics, and polychlorinated biphenyls at 5 toxic substances. 3 major types of potentially toxic agents are carcinogens, mutagens, and teratogens. And they are, as we know, that they cause cancer, they cause mutation in DNA molecules, and they are very much known to our society. Some chemicals may affect our immune and nervous system. Our body's immune system protects us against diseases, and the chemicals interfere with this process. So these are the chemicals: arsenic, methyl mercury, and dioxins. Neurotoxins are there. Neurotoxins can harm the human nervous system. Because of neurotoxins, behavioral changes are observed, learning disabilities are seen, retardation is observed, attention deficit disorder is there, paralysis may occur, and ultimately death can also be seen. Some chemicals may affect our immune and nervous system. These neurotoxins are polychlorinated biphenyls, methyl mercury, arsenic, lead, and certain pesticides. Now, how to protect the mercury pollution? So we know that incinerators are there. So if you want to reduce the mercury, then we have mercury pollution. Then we have to reduce or remove mercury from coal before it is burnt. Switch from coal to natural gas, and because of all these things, we can reduce. We can stop using the recycled batteries, because the lead and mercury are present there. Some chemicals affect the human endocrine system, and these are the hormones that regulate human reproduction, growth, development, learning ability, and behavior. Some chemicals affect the human endocrine system, harmonically active agents, and because of the aluminum, atrazine, DDT, PCBs, mercury, phthalates, and bisphenol, you can be affected. Your endocrine system is also affected adversely. Some chemicals affect our endocrine system, as I told you. So BPA is found in plastic water bottles, baby bottles, and the plastic resins. They are really harmful to human body, and in 2008 the FDA concluded that BPA in food and drink containers does not pose a health hazard. But in 2010, Canada classified BPA as a toxic chemical and banned its use in baby bottles. So there are companies which tell us that these chemicals are not harmful, but after 1 or 2 years, we come to this conclusion that no, these chemicals are very harmful to human health. Phthalates are also very dangerous for our health. They are found in detergents, perfumes, cosmetics, deodorants, soaps, shampoos, and in PVC products, which are being used as toys then teething rings and medical tubing used in hospitals. So phthalates are also very much harmful to human health, and we must understand that these phthalates are found in all these products. We are using shampoo, we are using soaps, we are using deodorants, but we should know that phthalates are present there and they are very harmful to our system. Then many factors determine the harmful health effect of chemicals. Toxicology is the study of the harmful effect of chemicals on human and other organs. Toxicity is a measure of the harmfulness of the substance, and log P is the parameter which determines the toxicity of chemicals, and the value of the log P is very much helpful in this direction. When we are talking about the drug molecules, then we are using term dose response curve for LD50. This is predicted here. This is depicted here. So when we are taking some medicine, then its response depends upon the curve. So the concentration of the drug is represented in many forms: IC50s, inhibition concentration, lethal dose concentration. These are the terms which are used. In our daily use, we are using so many things: nail polish, shampoo, teddy bear, clothing, baby bottles, mattresses, carpets, TV, sofa, then milk products, then hairspray, food, perfume. They all contain harmful chemicals, and I have listed some of these chemicals which are available in our drawing room or in our house. So nail polish, then perfluorochemicals are, phthalates are there, shampoo, then teddy bear, clothing, then baby bottles, bisphenols are there, then mattresses, carpet, that the padding and carpet fibers contain flame retardants. So you can understand that whatever we are using, we are full of harmful chemicals in our surrounding. Now I'm going to talk about the viral diseases and parasites which kill a large number of peoples. And viruses evolve quickly, are not affected by antibiotics, and can kill large number of people. The biggest killer is the influenza or flu virus, which is transmitted by the body fluids or airborne emission of an infected person. The second biggest viral killer is the human immunodeficiency virus. HIV infects about 1.8 million people each year, and the complications resulting from AIDS kill about 1.8 million people annually. And now is the coronavirus. The third largest viral killer is the hepatitis B virus, which damages the liver and kills about 1 million people each year. It is emergent diseases are illness that were previously unknown or were absent in human population for at least 20 years. And now we are working in those viruses. Sometimes we are talking about the new viruses, bird flu, swine flu. These were not known in early days, but now within 30 years, 40 years span of time, we are coming to such researches that tell us about these viruses. So greatly, viruses are affecting our immune system. Then we have to be very careful. Nowadays we are saying that social distancing should be observed. We should not touch each other, avoid touching your face, stay away from people who have flu or other viral diseases. So these are some of the preventive things which are advised. Now we know that the 47% of the population live in areas where malaria is prevalent. So our country is also infected by the malaria parasites, and people are suffering even nowadays from malaria. Falciparum malaria is one of the deadly disease which is really causing death to human being. Here I have given one figure which gives the pathways how the water and our environment is infected, how this cycle works. So here you have surface water. So surface water, then it is going downwards towards earth, it is going to atmosphere, then the crop in the environment is affected, the animals are affected, vegetations are affected, then the groundwater is also affected, soil is affected, then water table is decreased or increased. Sometimes if you recharge the groundwater, then you can get the water table upwards, otherwise it is going down. So this is the cycle which is prevalent, and it is affecting the environment. When we put some toxic chemical in our water body, then it is affecting the entire environment, whether it is the vegetation, soil, or the groundwater. Many factors determine the harmful health effects of chemicals. Then toxicity also depends on genetic makeup, which determines an individual's sensitivity to a particular toxin. Some individuals are sensitive to a number of toxins, a condition known as multiple chemical sensitivity. How well the body's detoxification system, such as the liver, lung, and kidney, work. Solubility, water-soluble toxin and oil or fat-soluble toxins. Persistence or resistance to breakdown, such as DDT and PCBs. Biological magnification, in which the concentration of some potential toxin in the environment increase as they pass through the successive trophic levels of the food chain and webs. The damage to health resulting from exposure to a chemical is called the response. Acute effect is an immediate or rapid harmful reaction ranging from dizziness and nausea to death. Chronic effect is a permanent or long-lasting consequences, like your kidney is damaged or liver is damaged because of the single dose or two repeated lower doses of a harmful substance. Are trace levels of toxic chemicals are harmful? Sometimes this type of questions are coming into picture. Almost everyone is now exposed to potentially harmful chemicals that have built up to trace levels in their blood and in other part of their bodies. A research shows that even the mother's milk contains DDT. So this is really a dangerous situation. Possible potassium long-term effects on the human immune nervous and endocrine system. So how our knowledge of chemistry helps the society for these ailments, for these toxic chemicals? So we know that before your treatment starts, doctor advises you to go for certain checkups. Now these diagnostic tools are all developed because of the knowledge of chemistry. So in advanced hospitals, you have automated chemistry labs where you give your blood sample at one table, and your entire analysis is performed with that sample. So that automated chemistry lab analyzes the entire parameters of human blood, stool, urine, and a diagnostic report is prepared, and then doctor decides what type of medicine is to be given. Now these systems work on the basis of the spectrophotometers, electrophoresis system, and ion selective electrodes. So automated instrumentation helps diagnostic of problems related to human health. I'm not going into detail of the spectrophotometer because we know that we are using for diabetes, we are using instruments in our home, and you put your one drop of the blood and your sugar level is determined. So it works on the principle of spectrophotometer, that is the Beers-Lambert's law. Now, electrochemistry also helps in that direction. Electrophoresis is the process measuring migration of charged solute particles. So, what kind of drug is to be delivered? So, your blood-brain barrier, these particle size are very important. So, electrochemistry, study of chemical reactions are important. And when you are taking any kind of liquid or saline water, so your this system starts working. So electrochemistry is also very much helpful in this system, especially measuring migration of charged solutes, particles, proteins, etc. And selective electrodes. So sodium potassium imbalances are found when your kidney is damaged. So the ion selective electrodes are working there. So you can use this technique where the ion selective electrodes principle is operated. Now, another diagnostic tool is X-ray. Each one of us know that X-rays are very common. Now, when Professor Ranjan discovered this technique, nobody thought that it will be going to be used for the betterment of the human life. So, X-ray is a technique which is electromagnetic radiation. Most X-rays have the wavelength of 0.01 to 10 nanometers, corresponding frequencies in the range of 30 petahertz, and these energies when transmit from human body, then you can take the picture. So it was discovered in 1895. Ranjan discovered this technique, and now it is very much useful as a diagnostic tool. What is the use of X-ray? Based on the energy of the radiations, X-rays have wide range of use. Used in X-ray scanners, X-ray crystallography, industrial radiography, and CT scanning. X-ray has an immense role in the medical field, diagnostic as well as therapeutic. Now, if you have some malignancy, then you can use the X-rays for that purpose also. X-ray is the most preferred tool for detecting any bone-related problem such as fracture, tumor, degenerations. It is also used to detect abscesses like pulmonary tuberculosis, lung abscess, etc. And for therapeutic use, to kill malignant cells, cancers, for the treatment of cancer. This is two picture of the X-ray of the ribs and the lung. Now, CT scan is the advancement of the X-ray, and it is a very useful tool for diagnostics. When X-ray passes through the human body, some of the rays are absorbed and some pass through the body to produce an image. In plain X-ray imaging, the film directly absorbs penetrated X-rays. In CAT scanning, an electronic device called the detector arrays absorbs the penetrated X-rays, measures the X-ray amount, and transmits the data to a computer system. So in CT scanning, you have a detector, and in plain X-ray, you have a film. So the detector is giving a very sharp image of X-ray. The picture of the X-ray. So diagnostic is perfect in CT scanning. So nowadays, plain X-rays are not preferred. Most of the time, it is the CT scan which is preferred. So here we have two CT scan. One of the normal kidney and another is the diseased kidney. You can see the picture here. In normal kidney, you can visualize the kidney. It is very sharp image is there, and when it is the diseased kidney, the shrink portion of the kidney is visible here. Calculi are there, so stones are there. So this is the diseased kidney. So the CT scan is very useful, uh, which is based on the principle of X-ray. So CT scan is also very much helpful in the scanning of the brain, and this is one of the image of the brain scanning. Now the latest technique is the MRI, which is very common for the scanning of the entire brain and body scanning. So MRI is a radiology technique that uses magnetism, radio waves, and a computer to produce images of body structure. MRI is based on the principle of nuclear magnetic resonance, and in 1997, the first MRI exam was performed on a human being, and it took almost 5 hours to produce one image. But now you can see that MRIs are very common. You go to any scanning center, you have to wait because there may be a big queue, but within half an hour you will be free because it is the technique which is now very sophisticated and very modern and very easy to use. What can be diagnosed by an MRI scan? Most element of the brain, including tumors. You can diagnose tumors, sports kind of injuries, muscular skeleton problem, most spinal conditions injuries, vascular abnormalities, female pelvis problems, prostate problems, gastrointestinal problem, certain ear, nose, and throat problem, and soft tissues. So all these things can be diagnosed by MRI. The principle of MRI, as I told you, that is it is the technique, the principle of NMR. The MRI makes use of the magnetic properties of certain atomic nuclei. Hydrogen nuclei, single proton, present in water molecules, and therefore in all body tissues, water is available. The hydrogen nuclei partially aligned by a strong magnetic field in the scanner. The nuclei can be rotated using radio waves, and then they subsequently oscillate in the magnetic field while returning to equilibrium. Simultaneously, they emit a radio signal. This is the detected using antennas, coils, and very detailed images can be made of soft tissues. So this is the picture of how hydrogen is arranged in the body, and after the strong magnetic field, they align in one direction. So this is the haphazard distribution of the hydrogen nuclei, and now this is the when you apply the magnetic field, then because of the spinning of the nucleus, you have the precisional orbits, and this technique is used there. So this is the MRI scanner. So there is a radio frequency coil, there is a gradient coil, magnets are there, and then there is a patient table. You can lie down on this table. It can rotate 360-degree. Then when the NMR technique is applied using the radio frequency coil and the magnet, then the fluid hydrogen in the fluid, this nucleus is arranged, and ultimately you get a image. So this is the scenario. The upper portion is human body is full of random magnets, and then when you apply the magnetic field, then they arrange in one direction. So this is the technique of MRI, and it is very commonly used and very effectively used. Here I have depicted some of the images, MRI image. Here this is the brain and the face. Here is the skull, and here is the backbone, and you can see the sharpness of the image. When I joined, there was a lecture going on that was the gold nanoparticles. So I'm also going to tell about the nanoparticles and how they are useful in the treatment of the malignant cancer cells. So as you know that the cancer is a disease where cells grow out of the control, invades, erodes and destroy normal tissues. So chemotherapy is the technique and radiation is the technique available for the cure of the cancer. Now, the nanotechnology based drug delivery system has been developed. Now, you know the nanoparticles, the size is very important. So here there is a scale of the size from tennis ball to nano devices. They are in the terms of 10 raised to the power and 10 raised to the power minus. Now, nanoparticles as drug delivery systems enables unique approaches for cancer treatment. Nanoparticles have optical, magnetic and chemical and structural properties that set them apart from bulk solids with potential applications in medicine. Because of these properties, they are very much helpful and applicable in the field of the medical science. So gold nanoparticles exhibit a combination of physical, chemical, optical and electronic properties. And gold nanoparticles play a multifunctional role in image and diagnose diseases, deliver of therapeutic agents and administer electromagnetic radiation to diseased site. Gold nanoparticles are emerging as promising agents for cancer therapy. These are beneficial in diagnosis of cancer due to their photophysical property and optical property. Unlike conventional cancer treatment, the golden nanoparticles approach uses no toxic chemicals and no radiation, reducing the risk of unpleasant side effects. We know that when somebody is suffering from cancer, and the person takes either radiation or some chemotherapy is given, side effects are too much. Hairs are gone, then vomiting is there, nausea is there, so many problems are there. Burning sensation is there. So, but the gold nanoparticles are very much helpful in this direction. This therapy will work on any soft tissue tumors such as the breast, prostate, brain, skin, head, neck, and cervix. Anywhere it can be used. The nanoparticles are designed to convert light into heat, blasting away the surrounding cancerous tissues. Because of their special property, if you convert light into heat, so gold nanoparticles are heated and they burn the malignant tissues, and therefore unlike the common medicine for the treatment of cancer, when drugs are administered to the body, then they kill the malignant cell as well as the normal cell. So the damage is too much. But in gold nanoparticles, the normal cells are saved. So gold nanoparticles occur as clusters of gold atoms up to 100 nanometer in diameter. Nanogold has unusual visible properties as the particles are small enough to scatter visible light. Mass gold reflects light. Gold nanoparticles appear deep red to black in the solution. Color depends on the size of nanoparticles. Then surface plasmon response is the term used by nanotechnologists in biosensing. So here we have the 5 nanometer gold cluster, color is different, and here this is gold nanoparticles, color is different. So characteristic of gold nanoparticles. Gold nanoparticles are chemically inert. These have greater biological compatibility. Optical properties like plasmon resonance are fluorescence and chemiluminescence, having better exhibition by gold nanoparticles. Gold nanoparticles provide microscopic probes for the study of the cancer cells. Gold nanoparticles accumulate in the cancerous cell and show the cytotoxic effect, that is apoptosis or necrosis of the specific cell and cell specific receptor. These have high stability due to the gold sulfur bonds. So gold nanoparticles designed for photothermal therapy, then the wavelength of maximal absorption, then absorption cross section, size of particle, and gold is a good conductor of heat. Gold nanoparticles are able to heat it up by radio frequency, and the heated nanoparticles would in turn heat the cancer cell and make it destroyed. So this is the mechanism of the gold nanoparticles for the treatment of the malignant cancer cell. And here is the picture. When we are using the traditional treatment, then drug is administered, so it goes to cancer cell. Sorry, cancer cell, and these cancer cells are destroyed, and because of these drugs, the normal cells are also destroyed. But when we are using nanotechnology treatment, nano devices are there, the cancer cells, the nanoparticles, the gold nanoparticles are administered. They are just surrounding the malignant part of the malignant part of the cancer cells, and the other normal cells are saved. So this is the mechanism how the gold nanoparticles are working. So I think I will stop here, and this was some of the idea how the knowledge of the chemistry is helping the human health, starting from the nutrients, the drug molecules, the gold nanoparticles, the techniques of the X-ray, NMR, MRI, CT scan, and then lab testing also. So thank you very much for giving me a patience hearing.
Thank you so much, sir, for sharing your deepest knowledge through this webinar and enlighten us with the achievements done in the field of chemistry. Thank you so much for your visionary words once again. Now, our next esteemed speaker is Dr. Vandana Pandey. She is Assistant Professor in the Department of Chemistry at Kurukshetra University, Haryana. And her topic for today's discussion is chemicals in food. May I request and invite Dr. Vandana Pandey to please join us and have her words of wisdom with us. We welcome Dr. Vandana Pandey.
Thank you very much for inviting me on this platform. Now I am going to deliver my lecture on the topic, which is chemicals in food. Is it visible? Is it visible to all of you?
Yes, ma'am, it is visible.
And am I audible also?
Right, ma'am.
Oh, thanks.
Please continue.
So my topic is very simple and just relevant. It is chemicals and food. I am Vandana Pandey, working in the Department of Chemistry, Kurukshetra University, Kurukshetra, Haryana. So you know that in the present day scenario, this topic becomes more relevant to all of us because lifestyle change and more intake of processed food make us more prone to health related problems, which can be sometime ultimately convert to more chronic diseases. And you know that food is one of the basic need of human being for the normal functioning of body part and for a healthy growth. As the sir said earlier, that I will continue to that food is basically chemical form of energy. It is defined as any substance having nutrients that is either eaten or drunk by any animal, including human, for nutrition or pleasure. Food is basically, as I said, that this is a chemical form of energy. We all derive food from basically, ultimately from sun. Since the sun is the source of energy, solar energy get converted in the form of food, carbohydrates, the process of photosynthesis, and these plants we consume either directly or indirectly to fulfill our nutrition requirement. There are six basic composition of food: water, carbohydrates, as you know, proteins, dietary fiber, fats, vitamins, and mineral. Water, you know, basically food is composed of water, and water is present in either in crystalline form or in other form in many of food. Second one is carbohydrate. Carbohydrate, as you know, these are also known as saccharides. They are compounds made up of carbon, hydrogen, and oxygen. Chemically, they are polyhydroxyaldehyde or ketone, and they are classified as mono, oligo, and polysaccharide. They are main source of energy. They also act as a storage of energy. They also act as a structural component, and approximately 50 to 55% of total
चलो
daily
रुको थोड़ी देर, हम चल के पूछते हैं, आधा घंटे रुको.
carbohydrate. But I am going to explain some another terms associated to carbohydrate. First one is refined and unrefined carbohydrate. Carbohydrate may be refined or unrefined. Refined means food is highly processed. The fiber and bran of various vitamins and minerals have been removed, whereas unrefined are complex carbohydrate. They are having slow release. And another terms which is associated to carbohydrate is GI and GL. GI is glycemic index and GL is glycemic load. So GI is a scale which represents how quickly carbohydrate consumption increases blood sugar level. When we eat carbohydrate, it gets dissociated into glucose. Ultimately, it gets dissociated into glucose. And how quickly its consumption increases blood glucose level, it indicates its GI, glycemic index value, and it ranges from 1 to 100. And 1 to 10 means food with low glycemic index, 11 to 19 some medium glycemic index, and then 20 onward, and the food has high glycemic index. Second one is glycemic load. Glycemic load is a ranking system for carbohydrate rich food. It basically gives information about overall effect that a food has on blood glucose. Since food is composed of not only carbohydrate but various other nutrients also. So glycemic load gives information about overall effect that a food has on blood glucose. For example, it can be calculated by using simple formula, that is GI is equal to GL is equal to GI into amount of carb per serving upon 100. I am repeating it. GL glycemic load is equal to GI glycemic index multiplied by amount of carbohydrate per serving upon 100. So basically GL is more important because it gives information about carbohydrate absorption in total feed. For example, peanuts have GI 14, and if a serving size is 130 gram, it had carbohydrate portion 15. So 15 into 14 upon 100, it gives you glycemic index value that is around 2. Similarly, we can see that any other example such as white rice. Rice has GI glycemic index 64, high glycemic index it has because of it is of a rich carbohydrate, having more carbohydrate present in it. And 1 cup of serving, which is approximately 186 gram, has approximately 52 portion of net carbs. Then 52 multiplied by 64 divided by 100 gives you approximately 33 value of glycemic load. So in this way we can calculate glycemic index as well as glycemic load of various carbohydrate rich food and it gives you information about totality. It gives you information about overall effect that a food on blood glucose level, because you know that blood glucose level is associated in different type of disease such as diabetes. Second one, important constituent of food is protein. All you know that proteins are polypeptides made up of amino acid. Amino acids are compound made up of carbon, hydrogen, nitrogen, oxygen, and sulfur. Proteins play an important role in our body. They act as a structural component. They act as enzymes. Enzymes are biocatalysts. They initiate and regulate various biochemical reactions in our body. They also act as hormone. There are around 20 amino acids required for our body. Out of these 20, 10 are known as essential amino acids. 10 are known as essential amino acid. Essential amino acid cannot be synthesized by the body. They are obtained from dietary sources. So we have to be careful about our protein intake. Approximately 60 gram of protein is daily required. There is a term associated with protein that is known as biological value. Biological value is the measure of proportion of absorbed protein from food, and it gives you information about protein quality, how readily it breaks down, and it can be used in the body. So whole egg has biological value 100, whereas as we go down this table, wheat has because of high carb content and less protein value, it has around 54. When we talk about peanut, it has approximately 68 by BV value. And you know that protein, when we eat protein, they just first get converted into higher polypeptide, then lower polypeptide, after that peptone, and ultimately they decompose to mixture of amino acid. Next one is dietary fiber. Dietary fiber are one of the most important constituent of our food. They are also called roughage, and they are basically indigestible portion of plant food. There are two main type of dietary fiber. First one is soluble, and which are generally obtained from fruit juice, and second one is insoluble, which is obtained from whole grain food and vegetable, and roughage, which is basically called. And what is the role of dietary fiber in our diet? It facilitates absorption and regulate blood sugar level, and also it regulates blood lipid level. So approximately 30 gram of fiber intake is recommended in daily diet. Chemically, we talk about dietary fiber. They are polysaccharide. So they are a type of carbohydrate, and various examples of dietary fiber are cellulose, inulin, lignin, pectin, beta-glucagon. So here some structures are presented. First one is cellulose. As you know that cellulose is a polysaccharide made up of various glucose units joined together by 1,4 beta glycosidic linkage. One carbon atom of one glucose unit is linked by a glycosidic linkage to fourth carbon atom of second glucose unit, and this one is goes on and we form cellulose fiber. This one is 1,3 and 1,4 beta glucagon. In 1,3 beta glucagon, first and third carbon atom of glucose monomer unit are involved in glycosidic bonding, whereas in 1,3 1,4 first, third and fourth carbon atom are of adjacent glucose molecules are involved in glycosidic bonding. All these are polymers. They are natural polymer, as you know, and this one is 1,3 and 1,6. So as the name suggests, first, third and sixth carbon atom of glucose units are involved in 1,3 beta glycosidic linkage. Next one is fat. Fat is nowadays it is much debated word in case of food technology. Fats are basically, we know that fats are triglycerides. They are triesters of glycerol and fatty acids. Fatty acids are long chain fatty acids. Generally, they are obtained from animal source. That's why they are known as fatty acids. And so fatty acids are main ingredient of fats. Fats can be physically classified into two categories: liquid oil and fats, solid fats. So, but chemically, when we classify fat, they are saturated fatty acid or unsaturated fatty acid. As the name suggests, saturated fatty acid has no unsaturation in the carbon chain. They have carboxylic group at the one end and saturation on the entire chain. So saturated fatty acids have no unsaturation. Whereas unsaturated fatty acid can be classified again into two categories: monounsaturated fatty acid as well as polyunsaturated fatty acid. Monounsaturated fatty acid, as the name suggests, they have only one carbon-carbon double bond, carbon-carbon unsaturation in the entire fatty acid chain, whereas polyunsaturated acid has more than one unsaturation present in the carbon-carbon double chain. And now unsaturated fatty acid can be cis or trans depending upon the configuration around the double bond. If both hydrogen atom and side chain are in same position, then it is called cis fat. Whereas if both hydrogen atom and as well as carbon chain is on opposite side, it is known as transport. So when we talk about the overall effect of these fatty acids, trans fats are not bad at all. They are good in some extent because they increase both LDL as well as HDL. LDL is low density lipoprotein, which is bad for health, whereas HDL is high density lipoprotein, which is good for health. So when we talk about saturated fatty acid, they increase both LDL as well as HDL. But when we talk about polyunsaturated fatty acid, trans fat are harmful for our body because they generally increase bad cholesterol as well as they decrease good cholesterol in the body. So when you see the labeling in the food product when you purchase, it should be labeled as free of trans fat. Next process is the hydrogenation. Hydrogenation is conversion of unsaturated fatty acid into saturated. When that means conversion of double bond into single one. So when complete hydrogenation takes place, saturated fats are formed. They are generally cis in nature, but sometimes chemical hydrogenation resulted in the form of trans fat. This is partial hydrogenation which resulted in the form of trans fat. So generally hydrogenation is carried out to increase the storing age, or to make it more shelf. It has increased shelf life. So that's why hydrogenation is carried out. But hydrogenation sometimes resulted in the formation of trans fat. Next topic is which is associated with fat is fatty acid, omega-3 fatty acid. Omega-3 fatty acids are known as polyunsaturated fatty acid, PUFA. If you read the label of your chips or wrapper packets, so sometimes it may contain PUFA. So, or more precisely, SC PUFA, short chain polyunsaturated fatty acid, omega-3 fatty acid. Omega-3 as well as omega-6 fatty acids are good for health. Both are PUFA. So when we talk about omega-3 fatty acid, these are short chain carboxylic acid. So carboxylic group is one end, and from the carboxylic group, carbon atoms termed as alpha, beta, and gamma, and last carbon is termed as omega. And from this omega carbon, if unsaturation is present, first unsaturation is present at third position, then it is termed as omega 3 carbon. So when we name them, so Ella 18, 3 and 3, this one is example of omega 3 fatty acid, which is good for health. 18 number is the number of carbon present in this fatty acid, so total 18 carbons are present. And first 3 is the number of double bond present in this polyunsaturated fatty acid, so 3 double bonds are present, and N3 is first double bond is presented, omega 3 format. So these are some example of omega 3 fatty acid, and most known is DHA and DPA. DHA has 22, 6 and 3. It means it has 22 carbon atom present in it, and 6 double bonds are present in it, and first unsaturation present at third position, that is omega. From terminal carbonate, it is present at third position. Similarly, omega 6 fatty acids are also good for health, and they on the similar fashion, they are short chain polyunsaturated fatty acid having carboxylic group at the one end, and last carbon is termed as omega carbon. Here first unsaturation is present at sixth position. So this one is La 18, 2 and 6. So this omega 6 fatty acid contain 18 carbon atom in this chain, and 2 unsaturation, 2 double bonds are present in this chain, and first unsaturation is present at sixth position. That's why it is termed as omega 6 fatty acid. Both omega 3 and omega 6 are good for health, and nowadays commercial are just explaining this very loudly in their product. Next composition constituent of our food, these are natural constituent are vitamins and minerals. Vitamins and minerals are substances which are required in minute amount. Vitamins, you know that these are organic in nature, whereas minerals are inorganic in nature. And these are essential for normal growth and development. Generally, vitamins and minerals can be taken from food sources, but they are very essential for normal growth and development, and deficiency lead to some type of disease. They are required in minute amount. Basically, they are required in very trace amount, and you know that water soluble vitamins are B and C, and fat soluble vitamins are A, D, E, K. So fat is also necessary for dissolving these vitamins, so they may function properly. Minerals, apart from carbon, hydrogen, oxygen, some other elements are required for proper functioning of body, such as calcium, potassium, phosphorus, magnesium. Some other are required for in minute amount, micro amount. They are known as micronutrients, such as copper, iodine, iron, selenium, zinc. Iodine is, you know that it is required for proper functioning of thyroid gland. Iron is for hemoglobin, and zinc is active constituent of various enzymes, and we can say selenium is an antioxidant. It acts with vitamin E, and copper is associated with iron functioning. But as you know that raw food is best source of nutrient, but every time when we prepare food or process food, it reduces amount of nutrient. It also reduces freshness, appearance, and sometimes it changes entirely. But it is not possible to get food all the time. We have to store them, we have to cook them, we have to preserve them for future use. So conversion of raw food material into acceptable food product by various means is called processing of food. So processing of food can be done by various ways such as dehydration, freezing, heating, fermentation, preservation. Processing not only reduces nutrient but also sometimes it reduces new chemicals. Sometimes they are maybe harmful. So such as HCA, that is heterocyclic amines, and they are produced at high temperature, and PAH, and these, as I sir said, that it is one of the most dangerous pollutant present in on the atmosphere, polycyclic aromatic hydrocarbon. These are produced by the process of auto-oxidation, lipolysis, thermal decomposition. But you know that increasing population, storing necessity leads to processing of food. So food processing of food can be done by using addition of some chemicals, and addition of some chemical, these chemicals are known as food additives. So food additives are chemical substances added to food to preserve or enhance flavor or to improve its taste and appearance. Food additives are added intentionally. We add them intentionally to incorporate some properties to the food and are not naturally a part of food. So part of natural constituents are, as I said, the six constituents are there, but we add food additives intentionally. There are functions of food additives. They maintain food consistency, they improve and maintain nutritive value of food products, they maintain palatability and wholesomeness, they and impart desired color, and they provide leavening and controlling acidity or alkalinity during storage and transportation. There are four basic categories of additives, chemical additives. These are nutritional additives, processing agent, preservative, sensory agent. They are colorant and flavoring agent. Both are involved with our senses. So first is nutritional additives. Nutritional additives, as the name suggests, they are added into the food to increase nutritional value. They are used for restoring nutrient lost or degraded during production, fortifying or enriching certain food in order to correct dietary deficiency or adding nutrient to food substance. So they are added externally into the food to fulfill the nutrient deficiency or to enrich the food with particular type of nutrient. So some common examples of nutrients are iodine, vitamin A, D, E, and C. And this one is, you know, that structure of vitamin A, retinol, which is get converted into body into retinaldehyde, then retinoic acid, I2, which is essential for normal functioning of thyroid gland, generally present in common salt, table salt. Vitamin A, D, E, and C are present in various food. So you can see the label enriched with vitamin C, enriched with vitamin A and D, and so on. Generally, oil and vegetables are enriched with vitamin A, D, E, and like that. Second one is processing agent. Processing agents are those compounds which are used to impart some or other kind of, we can say, some or other kind of action in the food, such as anti-caking agent. They are used to prevent cake formation in salt, such as sodium aluminosilicate is used for this purpose, and bleaching agent to in flour. Benzoyl peroxide is used as a bleaching agent in flour to make it white during storage. And chelating agent, some metal is present in the biochem food, they may act as a catalyst. So they act as a catalyst, they form, they are ideal site for oxidation reaction. So EDTA can be used for a chelating agent to trap these metals, and these are used as various dressing, mayonnaise, sauces, dried bananas. Clarifying agents are used to clear the turbidity in the shake and juice, fruit juices and wine. Bentonite is used for this purpose. Generally, conditioning of flour is for this purpose. Potassium bromate is used to next is emulsifying agent. The emulsifying agents are used to facilitate uniform distribution of oil in aqueous media, and this particular task, lecithin, agar-agar, pectin are used, and these are extremely used in case of my ice cream, mayonnaise, bakery products. Leavening agents are used to introduce carbon dioxide in the dough but better. So for that for leavening agent, yeast is used, baking powder, baking soda are used as a leavening agent in bakery product and various fermented diseases. When we talk about fermented diseases, especially South Indian, so we use leavening agent. Moisture control or humectants such as glycerol is used to maintain moisture content in marshmallows for candies and chewing gum. pH control during the storage and transportation. pH may be changes, food may be more acidic or sometimes it may be alkaline. So for this maintain pH, citric acid, lactic acid.
Sorry to disturb you, madam, but we are request you to please wind up as we are having some shortage and other programs to continue through this platform.
So stabilizing and thickening agents are used. So some preservatives are used. Preservatives are used to preserve the food during storage and transportation. They are antioxidant and antimicrobial. Ascorbic acid, BHA, BST are used as a antioxidant, whereas these are some structure, whereas antimicrobial are used to prevent microbial growth, and acetic acid, benzoic acid, sodium benzoates are used as a antimicrobial substances. Colorants are used to impart new color or to restore color loss during processing. Some natural food colorants are used. Food, not only these additives, but some food components are also present in our daily food. Some are drug residues, fertilizers, and other growing aids incorporated during agricultural practice. Chemical due to irradiation when food is cooked by a microbial or other electromagnetic field. Some chemical may be formed. Microbiological contamination may be there, presence of fungus and bacteria. Naturally occurring food toxicant may be there. Pesticide may be there due to agricultural practices and use of more pesticide in agricultural practices. Some environmental contaminant may be there, and adulterant. These are most important. Adulterant. Adulterants are compound which are intentionally added into the food which adversely affect the nature and quality of food. So some common food items and their adulterant such as in milk, antibiotic, sodium bicarbonate, urea, water, sugar, starch, foreign fats are present. In spices, non-permitted color, mineral oil are present. So these are adulterants. Emerging issues in food nowadays, organic food, as you know that they are obtained from organic sources, food grown without application of synthetic fertilizer and pesticide, and processed according to certain production standard. But they are costly and they are in high demand, as you know nowadays. GM food, genetically modified food. This one is we can say controversial term. GM food, genetically modified. They are prepared by modifying gene and introducing some new quality in gene. But the problem is their long-term health hazards are not known. Irradiated food, generally food are prepared by irradiation of microwave and other electromagnetic rays, so they are known as irradiated food. Freeze dried food are food in which dehydration of frozen food is performed to reduce weight and to make it available for transportation. Next is neurocortical and functional food. Neurocortical and functional food both are new types of food which are which provide health benefit, and they act as a direct dietary supplement. They are included in specific diet, and they add some specific body function mechanism such as oats. It balance cholesterol, you know all that. Flaxseed is consumption of flaxseed is common. It also reduces cholesterol. Use of garlic